Hi friends, my name is Maruti and I'm the co-founder of Kraku. In this video, we'll be looking at 90 plus questions from the modern maths topic for CAT. This is an important topic and many students actually ignore this topic quite a lot. But I would recommend you to go through this video because many questions actually come from this particular topic in the examination. If you found this video to be useful, I would recommend you to check out two playlists that we have. One playlist is the CAT revision playlist where we are having two videos where the entire concepts, all the important formulae for CAT are explained. There is one video where you can revise the entire portion for verbal within 1.5 hours, and there is one video where you get the basics of all the important types of LRDs that are asked. This is the CAT revision playlist and it is watched by lakhs of people. The second most important playlist is the set of topic-wise questions that we have made, similar to the one that we have made in this particular video. You will find topic-wise questions in arithmetic, algebra, geometry, modern maths and number systems. Again, lakhs of students have watched this question videos, so definitely check out the playlist of the topic-wise questions as well. The links for both of them are given in the description of this video. If you find this video to be useful, please do like it, and if you are having trouble with any of the questions that I have solved in the video, please do comment below this video. I look at all the comments and I'll try to respond to them to the best of my ability. In this question, we are told that x and y are positive real numbers such that log of x square plus 12 to the base x is 4 and 3 times log x to the base y is 1. We are required to calculate the value of x plus y. If you are looking at this equation, we are going to get that x square plus 12 is equal to x to the power 4. We can factorize this. Let us assume that x square is equal to a. Therefore, x to the power 4 is equal to a square. So, this equation essentially becomes equal to a plus 12 is equal to a square, or a square minus a minus 12 is equal to 0. This would imply that a minus 4 into a plus 3 is equal to 0. So the value of a is either equal to 4 or the value of a is equal to minus 3. A is x square, so it cannot be negative. So this is not true. So x square is equal to 4. So either x is 2 or minus 2. But again, we are told that x and y are positive real numbers. Also, x is part of the base of a logarithm, so x cannot be negative. So x is not equal to minus 2, so the value of x is 2. Once we know the value of x, from this equation we can calculate the value of y, because this would imply that log of x to the base y is equal to 1 by 3, or x is equal to y to the power 1 by 3, or y is equal to x cube. X is 2, so y is equal to 8. Therefore the value of x plus y is 2 plus 8, which is equal to 10, which is option C. In this question, we are given an equation square root of 5x plus 9 plus square root of 5x minus 9 is 3 times 2 plus root 2. We are asked to calculate the value of square root of 10x plus 9. In this question, we have one variable which is x and we have one equation. So we should be able to solve it. In these kind of questions, if you directly square this expression, you are going to get 5x plus 9 plus 5x minus 9 plus square root of 5x plus 9 into 5x minus 9, which is 25x square minus 81 is equal to the square of 3 plus 2 root 2. This looks messy because we will have the value of x outside the square roots, we will have the value of x inside the square root, so it just looks more complicated. The trick to solving these kind of questions is by taking one of these two to the other side. That is, we will make this as square root of 5x plus 9 is equal to 3 plus 2 root 2. Just for the sake of explanation, let this number be equal to k. So this is equal to k minus square root of 5x minus 9. Because now if you square both of the left hand side and right hand side, we will get 5x plus 9 is equal to k square minus 2k into square root of 5x minus 9 plus 5x minus 9. Now the difference to earlier is 5x gets cancelled. So we are going to get 2k into square root of 5x minus 9 is equal to k square minus 18. Now k is a constant, so we can calculate the value of k square. So we'll have only one term which is square root of 5x minus 9, which again we can take a square and calculate the value of x. That is what we are going to do. What is the value of k square? If k is equal to 3 times 2 plus root 2, the value of k square is equal to 9 times 4 plus 2 plus 4 root 2. This will be equal to 54 plus 36 root 2. That is the value of k square. So k square minus 18, which is the right hand side over here, will be equal to 36 plus 36 root 2. This is the value of 2 times. What is the value of k? K is 3 times 2 plus root 2 into square root of 5x minus 9. We can first cancel this 6 and divide this by 6, which will be equal to 6 plus 6 root 2. So 6 plus 6 root 2 is equal to 2 plus root 2 into square root of 5x minus 9, or root 2 into root 2 plus 1, which is basically equal to 2 plus root 2 into square root of 5x minus 9 is equal to 6 times root 2 plus 1. We can cancel root 2 plus 1. We can divide this by root 2, so this becomes 3 root 2. So the value of square root of 5x minus 9 is 3 root 2. The value of 5x minus 9 is the square of 3 root 2, which is equal to 18. Or the value of 5x is equal to 27. Or the value of x is 27 by 5. So what is the value of 10x? 10x will therefore be equal to 54. 10x plus 9 will be equal to 63. So square root of 10x plus 9 is square root of 63, which is equal to 3 times square root of 7, which is option C. In this question, we are told that there are some positive distinct real numbers x, y and z. We are told that the arithmetic mean of 1 by square root of x plus z and 1 by square root of x plus y is equal to 1 by square root of y plus z. What this would imply is that 1 by square root of x plus square root of z plus 1 by square root of x plus square root of y is equal to 2 by square root of y plus square root of z. Now we are required to calculate the relationship between x, y and z. If you are simplifying the left hand side, this is equal to square root of x plus square root of y plus square root of x plus square root of z divided by square root of x plus square root of z into square root of x plus square root of y is equal to 2 by square root of y plus square root of z. This seems very complicated, which involves a lot of square roots. But if you just cross multiply and simplify, you will get a fairly simple equation. How do we get that? We just cross multiply. This is 2 times square root of x plus square root of y plus square root of z into square root of y plus square root of z. What is the value of it? That will be equal to 2 times square root of xy plus 2 times square root of xz plus y plus square root of yz plus square root of yz plus z. What is this? This is just 2 times square root of x plus square root of y plus square root of z into square root of y plus square root of z. This has to equal 2 times square root of x plus z into square root of x plus square root of y. That is equal to 2 times x plus square root of xz plus square root of xy plus square root of yz. Now you will notice that on the left hand side we have 2 times square root of xy, we will cancel this. On the left hand side we have 2 times square root of xz, we will cancel this. We also have square root of yz 2 times, so we will cancel this. So what is the equation we have? We have the equation y plus z is equal to 2 times x. What does this imply? It implies that y, x and z are in an arithmetic progression, which is option B. In this question, we are told that there is a lab experiment where the number of organisms are measured every day at 8 a.m. On the first day, there were 2 organisms. On the second day, we have 3 more than twice that number. Twice that number is 4, 3 more than that is 7. On the next day, we have 3 more than twice that number. Twice that number is 14, 3 more than that is 17. The next day, we will have 3 more than twice the number, so that will be 37, and so on. Let us assume that on the nth day, the number of organisms is Tn. We need to calculate a formula for Tn. To calculate a formula for Tn, this is an arithmetico-geometric progression where there is a common ratio between terms and a number is added to it. This kind of a series is called an arithmetic-geometric progression. So let us assume that S is the sum of all the terms till Tn. That is, S is 2 plus 7 plus 17 plus 37 plus ... till Tn. Although we don't need to calculate the sum, just assuming that this is S makes things very easy. Why does it make easy? Because you can also write S as 2 plus 7 plus 17 plus ... plus Tn minus 1 plus Tn. We have just shifted each of the term 1 to the right. Now if you subtract the first equation from the second equation, the left hand side will be 0. S minus S is 0. The right hand side is 2 plus 7 minus 2 is 5, plus 17 minus 7 is 10, plus 37 minus 17 is 20, plus dot 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 dot, plus this will be, you can see that this is a geometric progression where the first term is 5 and the common ratio is 2. So this is into 5 into 2 to the power n minus 2 plus tn. Sorry, this will be minus tn. Or the value of tn, which is the nth term, is equal to 2 plus, you take 5 common and it will be 1 plus 2 plus dot 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 plus 2 to the power n minus 2. This is a geometric progression. The sum of this geometric progression will be 2 to the power n minus 1 minus 1. So tn is equal to 2 plus 5 into 2 to the power n minus 1 minus 5, which is equal to 5 into 2 to the power n minus 1 minus 3. You can substitute the value of n to be equal to 1. If n is 1, this will be equal to 2, which satisfies. If n is equal to 2, 5 into 2 minus 3 will be 7. If n is 3, it will be 5 into 2 square, that is 4. So that is 20 minus 3, which is 17. So you can see that the pattern is actually matching. Now for what value of n will this cross 1 million? So we want 5 into 2 to the power n minus 1 minus 3 to be greater than 1 million for the first time. This is 1000, 10,000, 1 lakh, 1 million. You can put this side. So basically we want 2 to the power n minus 1 to cross 2 lakhs 0.6 for the first time. What is the value of n minus 1? We know that 2 to the power 10 is equal to 1024. 2 to the power 7 is equal to 128. So you can infer that 2 to the power 17 will be something like 1.2 or 1.3 lakhs. So 2 to the power 18 for the first time will be greater than 2 lakhs. So the value of n minus 1 will be 18 for the first time, or the value of n has to be 19. So the answer for this question is 19. In this question, we are told that x is a positive real number such that x to the power 8 plus 1 by x to the power 8 is 47. We are required to calculate the value of x to the power 9 plus 1 by x to the power 9. We know that x to the power 8 plus 1 by x to the power 8 is equal to 47. So let us add 2 to both sides, plus 2 and plus 2. So the right hand side becomes 49 and the left hand side is x to the power 8 plus 1 by x to the power 8 plus 2. We know that x to the power 4 plus 1 by x to the power 4 whole square is equal to x to the power 8 plus 1 by x to the power 8 plus 2 into x to the power 4 into 1 by x to the power 4. This is basically x to the power 8 plus 1 by x to the power 8 plus 2. So what we essentially have is that x to the power 4 plus 1 by x to the power 4 is equal to 7. Let us repeat the same thing. Let us again add plus 2 here and plus 2 here. The right hand side is 9. The left hand side is x to the power 4 plus 1 by x to the power 4 plus 2, which is actually equal to x square plus 1 by x square whole square. This is equal to x to the power 4 plus 1 by x to the power 4 plus 2. So we will get x square plus 1 by x square is equal to 3. Let us again repeat the same process. Let us again add 2 here and 2 here. This is x plus 1 by x whole square. The right hand side is equal to 5. So what we are essentially getting is x plus 1 by x is equal to square root of 5. Once we have x plus 1 by x is equal to square root of 5, we are required to calculate the value of x to the power 9 plus 1 by x to the power 9. There are multiple ways in which you can do this. The simplest way is calculating the value of x cube plus 1 by x cube, and from that getting the value of x to the power 9 plus 1 by x to the power 9. How can we get the value of x cube plus 1 by x cube? We can just multiply x square plus 1 by x square into x plus 1 by x. X square plus 1 by x square we have calculated is equal to 3. X plus 1 by x is equal to root 5. This expansion we are going to get x cube plus 1 by x cube plus x plus 1 by x. That is the expansion of x square plus 1 by x square into x plus 1 by x. If you are expanding it, you are going to get x cube plus 1 by x cube. X square into x is x cube. 1 by x square into 1 by x is 1 by x cube. X square into 1 by x is x. 1 by x square into x is 1 by x. This, like we have calculated already, is equal to 3 root 5. we know that x plus 1 by x is equal to root 5. So the value of x cube plus 1 by x cube will be equal to 2 root 5. Once you have x cube plus 1 by x cube, how can we calculate the value of x to the power 9 plus 1 by x to the power 9? We'll just cube this. If you are cubing this, the right hand side will also be cubed, and that will be equal to 8, which is 2 cube, into square root of 5 whole cube, which is 5 root 5. So the right hand side is equal to 40 root 5. What is the left hand side? This will be equal to x to the power 9 plus 1 by x to the power 9 plus 3 times x cube into 1 by x cube into x cube plus 1 by x cube. You can cancel x cube and 1 by x cube. So essentially what we have is x to the power 9 plus 1 by x to the power 9 plus 3 times, what is the value of x cube plus 1 by x cube? X cube plus 1 by x cube we have already calculated over here, that will be equal to 2 root 5. So plus 3 into 2 root 5 is equal to 40 root 5, or the value of x to the power 9 plus 1 by x to the power 9 is equal to 34 root 5. So the answer for this question is option D. Just to reiterate, what we have done is, from x to the power 8 plus 1 by x to the power 8, we have calculated that x to the power 4 plus 1 by x to the power 4 will be equal to 7. From that we have calculated that x square plus 1 by x square will be equal to 3. From that we have calculated that x plus 1 by x will be equal to root 5. We have cubed this and we have calculated that x cube plus 1 by x cube is equal to 2 root 5. Now we have cubed this again, and if you are cubing this again, what are you going to get? You are going to get x to the power 9 plus 1 by x to the power 9 plus 3 into x cube into 1 by x cube into x cube plus 1 by x cube will be equal to the cube of 2 root 5, which is equal to 40 root 5. You can cancel these two. This is equal to 2 root 5. 3 into 2 root 5 is 6 root 5. So x to the power 9 plus 1 by x to the power 9 is 40 root 5 minus 6 root 5, which is 34 root 5. In this question, for a real number x, we are told that 3 terms, 1 by 2, log of 2x minus 9 to the base 3 divided by log 4 to the base 3, log of 2 to the power x plus 17 by 2 to the base 5 divided by log 4 to the base 5, all of them are in arithmetic progression. We are asked to calculate the common difference of the arithmetic progression. To solve this question, the first step that you need to know is the formula that log of a to the base b divided by log of c to the base b is equal to log of a to the base c. In this particular case, the 3 terms will be 1 by 2, comma, log of 2 to the power x minus 9 to the base 4. We have just applied this formula, and log of 2 to the power x plus 17 by 2 to the base 4. Again, we have applied the same formula. In the first case, the common base is 5. In the middle term, the common base is 3, which can be eliminated from the numerator and denominator. Now, 1 by 2 also we can write as log of 2 to the base 4. So the 3 terms which are in an arithmetic progression are log of 2 to the base 4, log of 2 to the power x minus 9 to the base 4, and log of 2 to the power x plus 17 by 2 to the base 4. If these 3 are in an arithmetic progression, the sum of the first term and the last term will be 2 times the middle term. This would imply that log of 2 to the base 4 plus log of 2 to the power x plus 17 by 2 to the base 4 is equal to 2 times log of 2 to the power x minus 9 to the base 4. If you assume that 2 to the power x is a variable p, the right hand side will become equal to 2 times p plus 17 by 2 is equal to p minus 9 whole square. This would imply that 2p plus 17 is equal to p square minus 18p plus 81, or p square minus 20p plus 64 is equal to 0. So p is either 4 or p is 16. But you would notice that p cannot be equal to 4. That is, if 2 to the power x is equal to 4, this logarithm will not be defined because we have 2 to the power x minus 9 as one of the terms. So 2 to the power x should be greater than 9 for this logarithm to be defined. So the only value of p is 16. So the three terms, that is 2 to the power x has to be equal to 16. The three terms which are in an arithmetic progression are log 2 to the base 4, log of 2 to the power x is 16, 16 minus 9 is 7, 7 to the base 4, and log of 2 to the power x again is 16 plus 17 by 2 will be 49 by 2 to the base 4. So the common difference is basically the sum of the middle term minus the first term, which is equal to log of 7 by 2 to the base 4. So the correct answer is option D. In this question, we are asked to calculate the value of 1 plus 1 by 3 into 1 by 4 plus 1 plus 1 by 3 plus 1 by 9 into 1 by 16 plus 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 into 1 by 64 plus dot 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 till infinity. If you are looking at the sum of a infinite geometric progression, if you have a geometric progression which is of the form ar square and dot 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 till infinity, and if r lies between 1 and minus 1, the sum of this geometric progression is a divided by 1 minus r. In this particular case, if you are looking at the contribution of 1 in all the brackets, that will be 1 plus this 1 into 1 by 4, that is 1 by 4, plus this 1 into 1 by 16, plus this 1 into 1 by 64, and so on. This is a geometric progression where the common difference, the common ratio is 1 by 4. So this will be equal to 1 divided by 1 minus 1 by 4, which is equal to 4 by 3. Let us now look at the contribution of 1 by 3 in all the brackets. That will be this 1 by 3. So this is 1 by 3 into 1 by 4 plus this 1 by 3 will have to be multiplied by 1 by 16 plus this 1 by 3 has to be multiplied by 1 by 64 and so on till infinity. This and this differ by a factor of 4. What do I mean by that? Over here, if you take 1 by 4 out, you are going to get 1 by 3 into 1 by 4 into 1 plus 1 by 4 plus 1 by 16 plus dot 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 till infinity. This we already know is equal to 4 by 3. We have just calculated that. So the contribution of 1 by 3 will be equal to 1 by 3 into 1 by 4 into 4 by 3. Similarly, if you are looking at the contribution of 1 by 9, that will be 1 by 9 into 1 by 16 plus 1 by 64 plus 1 by 256 and so on till infinity. Now you know exactly what we are going to do. We will take 1 by 16 out of the bracket. We will take 1 by 16 common. So this will be equal to 1 by 9 into 1 by 16 into again 1 plus 1 by 4 plus 1 by 16 plus dot 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 till infinity. This we know again is equal to 4 by 3. So the contribution of 1 by 9 will be 1 by 9 into 1 by 16 into 4 by 3. So the contribution of 1 is 4 by 3. The contribution of 1 by 3 is 4 by 3 into 1 by 12, which is equal to 3 by 4. The contribution of 1 by 9 is 4 by 3 into 9 into 16 is 144. That is actually 12 square into 1 by 144. So now if you look at it, you can take 4 by 3 common, and overall what we are getting is 1 plus 1 by 12 plus 1 by 12 square, which is 144, and so on till infinity. This is again a geometric progression where the common ratio is 1 by 12. So its sum will be 1 divided by 1 minus 1 by 12, which is equal to 12 by 11. So the answer is 4 by 3 into 12 by 11. This is 4. So this is equal to 16 by 11. So the answer for this question is option D. Just to reiterate what we have done, the first thing you have to remember is 1 plus 1 by 4 plus 1 by 16 plus dot 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 till infinity is equal to 4 by 3. Once you have calculated that, the contribution of 1 is 4 by 3. The contribution of 1 by 3 is, it is not starting with the first one, it is starting with 1 by 4, then you have 1 by 16, then you have 1 by 64 and so on. So automatically it is being reduced by 1 by 4, and this is 1 by 3 and not equal to 1. Essentially the contribution of 1 by 3 will be 1 by 4 plus 1 by 16 plus dot 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 till infinity. So if you take 1 by 4 also out, you will get 1 by 12 into our original sum. This is 1 plus 1 by 4 plus dot 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 till infinity, which is equal to the same number 4 by 3. So the contribution of 1 by 3 will be 4 by 3 into 1 by 12. Now the contribution of 1 by 9, we start off with 1 by 16 over here. 1 by 9 is not present in the first bracket or in the second bracket. It is present only when the coefficient is 1 by 16. So for 1 by 9, you have to take 1 by 16 out, and again you are going to get 1 plus 1 by 4 plus dot 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 till infinity, which is again equal to 4 by 3. So the contribution of 1 by 9, the third term will be 4 by 3 into 1 by 12 square. The contribution of the next one will be 4 by 3 into 1 by 12 whole cube. This is again a geometric progression. The sum of 1 plus 1 by 12 plus 1 by 12 square plus dot 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 till infinity, again using the original formula for geometric progression, is equal to 1 divided by 1 minus 1 by 12, which is 12 by 11. You multiply 12 by 11 with the coefficient which is common to all of them, which is 4 by 3. This will be 16 by 11, which is option D. In this question, we are told that AN is 46 plus 8n and BN is 98 plus 4n, where n is natural number which is less than or equal to 100. What is the sum of all the terms which are common to both these series? Let us look at the first series. You have 46 first, 46 plus 8, which is equal to 54. So the first term is 54, next term is 62, then you have 70, then you have 78, and so on. And the last term will be when n is equal to 100, and it will be 846. In Bn, the first term will be 102, next term is 106, next is 110, and so on. And the last term will be 98 plus 400, which is 498. If you are looking at the terms which are common to both of them, we have to first look at the first term which is common to both of them. After 78, you are going to get 86, then you will get 94, and finally you will get 102. So this 102 is the first term which is common to both of them. After 102 over here, you are going to get 110. This also will be common. Then you will have 118, which will be common. Then you will have 126, which is common, and so on. So the common terms themselves form an arithmetic progression where the first term is 102, second term is 110, third term is 118, and so on. And what is the last term? The last term will be 494. How can we calculate it? Because you can figure out that over here we have a difference of 8, and each of these terms, when it is divided by 8, you are actually going to get a remainder of 6. So 494 minus 6 is 488, which is also a multiple of 8. Another way to look at it is the first term of Bn is part of the common terms. The third term is common. The fifth term is common, and so on. And so the 99th term will also be common. So how many terms are there over here? You have 50 terms. The first term is 102, the last term is 494. If you are calculating the sum of an arithmetic progression where you know the first term and the last term and the number of terms, the sum is equal to the number of terms into first term plus last term divided by 2. That is, you take the average of the first term and the last term, you multiply it with the number of terms, you will get the sum of any arithmetic progression. In this particular case, that will be equal to 50 into 102 plus 494 divided by 2. Which is equal to 50 into 596 divided by 2, which is equal to 50 into 298. 50 into 298 is 14,900. So the answer for this question is option A. In this question, we are told that log x to the base root 3 plus log of 25 to the base x divided by log of 0.008 to the base x is 16 by 3. We are asked to calculate the value of log of 3x squared to the base 3. Now let us first calculate the second term of the equation. Log of 25 to the base x divided by log of 0.008 to the base x is equal to log of 25 to the base 0.008. But what is 0.008? 0.008 is 8 divided by 1000, which is equal to 1 by 125. 125 is 5 cubes, so this is equal to 5 to the power minus 3. So this is essentially equal to log of 5 square, which is 25, to the base 5 to the power minus 3. This is equal to minus 2 by 3. So the equation that we have is equal to log of x to the base root 3 minus 2 by 3 is equal to 16 by 3. If you take it to the right hand side, this is 16 plus 2 divided by 3, which is equal to 18 by 3, which is 6. So log of x to the base root 3 is equal to 6, or x is equal to root 3 to the power 6, which is equal to 3 cube, which is 27. So what is the value of log of 3x square to the base 3? That will be log of 3 times x square, which is 27 square, which is 3 to the power 6 to the base 3, which is log of 3 to the power 7 to the base 3, which is equal to 7. So the answer for this question is 7. In this question, we are told that there are two series A1, A2, A3 dot 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 and B1, B2, B3 dot 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 dot. Both of them are in arithmetic progression, and the common difference for both the series are prime numbers. We are told that A5 is equal to B9, A19 is equal to B19. We are told that B2 is equal to 0. We are required to calculate the value of A11. So let us assume that the common difference of the first one is say P1, which is a prime number, and the common difference of the second arithmetic progression is say P2, which is also a prime number. We are told that A5 is equal to B9. What is the value of A5? That will be A1 plus 4P1 is equal to B9, which is equal to B1 plus 8P2. Because the common difference for the second one is P2, the common difference for the first series is P1. We know that B2 is equal to 0. So this would imply that B1 plus P2 is equal to 0. So B1 plus 8P2 is equal to 7P2. What is the second one? We have this information that A19 plus is equal to B19. What is the value of A19? That will be A1 plus 18P1 is equal to B1 plus 18P2, which is essentially equal to 17P2. Why is that the case? Because B1 plus P2 is equal to 0. The second term of the second arithmetic progression B2 is equal to 0. Now using these two equations, if you subtract one equation from the other, the left hand side will be 14P1. This is equal to 10P2, or the value of 7P1 is equal to 5P2. What are P1 and P2? P1 and P2 are prime numbers. The only way this equation will hold is if P1 is equal to 5 and P2 is equal to 7. Now once you know that P1 is equal to 5 and P2 is equal to 7, we can calculate the value of B1. B1 will be equal to minus 7, because you want B1 plus P2 to be equal to 0. So what is the value of A1 plus 4P1, which is equal to 7P2? A1 plus 4 times 5, which is 20, is equal to 7P2, which is 7 into 7, which is 49. Or A1 is equal to 29. What are we required to calculate? We are required to calculate the value of A11. A11 is equal to A1 plus 10P1. A1 is 29. 10P1 will be 50. So this is equal to 79. So the answer for this question is option B. In this question, we are given two sequences. One sequence is AN, which is 13, 19, 25, 31, 37, 43, 49, and so on. The other one, the first term is 15 and the common difference is 7. So it is 15, 22, 29, 36, 43, 50, and so on. We are required to calculate the largest 3-digit number, which is common to both the sequences. In order to figure out the terms which are common to both the sequences, we have to first identify the first common term. In this case, the first common term is 43. And the common terms also form an arithmetic progression where the first term is 43 and the common difference is the least common multiple of 6 and 7. Because here the common difference is 6. Here the common difference is 7. So the common difference of the common terms will be 42. So this is 43 plus 42, which is equal to 85. The next one will be 85 plus 42, which is 127. Next will be 127 plus 42, which is 169, and so on. So we want the largest 3-digit number, which is part of the common terms. So that will be 43 plus 42D. This has to be less than or equal to 999. Or 42D has to be less than or equal to 956. D therefore has to be, this is 840 is 42 into 20. Then you add another 42, you have 882. You add another 42, you have 924. You add another 42, you get 966. This is greater than 956. So the largest value of 42D will be 24. In this particular case, D will be equal to 22. And therefore, the largest common term for both the sequences will be 43 plus 42D, which is 43 plus 924, which is equal to 967. So the answer for this question is 967. In this question, we are told that for any natural number n, suppose the sum of the first n terms is the arithmetic progression n plus 2n square. If the nth term of the progression is divisible by 9, what is the smallest possible value of n? So the sum of the first n terms is equal to 2n square plus n. Now what is the sum of the first n minus 1 terms? The sum of the first n minus 1 terms is equal to 2 times n minus 1 whole square plus n minus 1. What is the difference between the sum of the first n terms and sum of the first n minus 1 terms? If you are looking at the sum of the first n minus 1 terms, that is t1, that is the first term, plus t2, plus dot dot dot, plus the n minus 1th term. This is the value of s of n minus 1. If you add the nth term to it, here we are going to get the sum of the first n terms. So the difference between these two is basically the nth term. So tn, that is the nth term, is just the difference between these two. N minus n, the difference between these two is 1, and the difference between these two can be calculated easily. This will be 2n square minus 2 times n square minus 2n plus 1. This is equal to 4n minus 1. Overall 2n square will get cancelled. You will be having plus 4n minus 2 plus 1 is 4n minus 1. So the nth term of this arithmetic progression is equal to 4n minus 1. So the first term is 3, the second term is 7, the third term is 11, fourth term is 15, next term is 19, then we have 23, we have 27 and 31 and so on. The first term of this series, which is divisible by 9, is 27. And this is the 1, 2, 3, 4, 5, 6, 7. This is the 7th term. So the correct answer is option C.
Google search Crapo free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, we are asked to calculate the number of ways of distributing 20 identical balloons among 4 children such that each child gets some balloons but no child gets an odd number of balloons. Let us assume that the balloons with the 4 children are 2a, 2b, 2c and 2d because all of them are even numbers, and all of them a, b, c, d have to be greater than 0. So the equation we have is that 2a plus 2b plus 2c plus 2d is equal to 20, or the value of a plus b plus c plus d is equal to 10. Here we have all of them to be greater than 0. We want to use the equation, the formula for the number of non-negative integral solutions for an equation. That is, when you have r variables a1, a2, a3 plus dot 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 till ar, which sum up to n, such that each one of them a1, a2 dot 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 till ar are non-negative integers, that is, they are greater than or equal to 0. The number of solutions of this equation is n plus r minus 1 c r minus 1. But this formula is valid when this is greater than or equal to 0. Here we have all of them to be strictly greater than 0. So we'll assume that there are new variables a1 plus 1 which is equal to a, and b1 plus 1 is equal to b, and c1 plus 1 is equal to c, and d1 plus 1 is equal to d. Or the sum of a1 plus b1 plus c1 plus d1 is equal to 6. Now each one of them of the new variables a1, b1, c1 and d1 are greater than or equal to 0, and therefore the number of solutions for this equation will be 6 plus 4 minus 1 c4 minus 1. This is equal to 9c3, which is equal to 9 into 8 into 7 divided by 6. 9 into 8 is 72, divided by 6 is 12. This is equal to 84. So the answer for this question is 84. In this question, we are told that there are 100 students, and in that class, 73 like coffee, 80 like tea, and 52 like lemonade. We are required to calculate the maximum and minimum number of students who like all the 3 drinks. Finding out the maximum number of people who like all the 3 drinks is very easy. That will be equal to 52, because 52 people like lemonade. The maximum number of people who like all the 3 drinks has to be equal to 52, because 53 people cannot like all the 3 drinks. Because if 53 people like all the 3 drinks, that is not possible, as only 52 people like lemonade. So the case where the 52 people like lemonade, also like tea, and also like coffee will be the maximum possible value of the number of people who like all the 3 drinks. So anyway, the maximum number of people is 52. Calculating the minimum will take some effort. Here let us assume, because some people might not like all the 3 drinks also, let us assume that n people don't like any of the 3 drinks. So we have A people who like exactly 1 drink, B people who like exactly 2 drinks, and C people like exactly 3 drinks. And n people like exactly 0 drinks. So the value of A plus B plus C plus n is equal to 100. This is the total number of people who are there in that class. But we also know that the number of people who like coffee, tea, and lemonade, if you are combining all of them, that will be equal to A plus 2B plus 3C. This is equal to 73 plus 80 plus 52. Why is this the case? This is the case because if you assume that if you are calculating it from the number of drinks that are liked, that will be all the students who like exactly 1 drink, like only 1 drink. The number of people who like 2 drinks, that will be, if you are looking at the number of drinks that are liked, that will be 2 times that. And C people like all the 3 drinks. So if you are looking at the number of drinks that are liked, that will be 3C. Another way, another intuitive way of understanding this is, suppose you assume that if somebody has a drink, they get a flower. Now on a particular day, if somebody likes a drink, they drink it. So these A students, they get exactly 1 flower. These B students, because they have 2 drinks, they get 2 flowers each, or the total number of flowers given to them will be 2B. And these C students, each of them will get 3 flowers. So the total number of flowers given is A plus 2B plus 3C. This is one way of looking at it from the standpoint of the students. But if you are somebody who is at the drinks counter, you have some coffee, you have tea, and you have lemonade. You are not looking at the student. So the guy who is at the coffee stand gives 73 flowers. The guy who is at the coffee stand gives 80 flowers. And the guy who is at the lemonade stand gives 52 flowers. So the total number of flowers that are given will be 73 plus 80 plus 52. Both of them have to be the same. So this way, if you are looking at it from the standpoint of the students, you are going to get A plus 2B plus 3C. If you are looking at it from the standpoint of the drinks, you are going to get 73 plus 80 plus 52. This has to equal 153 plus 52 is 205. Or if you subtract the first equation from the second equation, B plus 2C minus n is equal to 105. Or B plus 2C is equal to 105 plus capital N. We know the maximum number of people who like all the 3 drinks. Now we are trying to find out the minimum value of C. So to get the minimum value of C, let us first make n to be equal to 0, because as n is increasing, C also will increase. So if n is equal to 0, we have B plus 2C to be equal to 105. And we have A plus B plus C to be equal to 100. This n is 0, so we will ignore it. If B plus 2C is equal to 105, the individual value of B has to be less than or equal to 100. So the minimum possible value of C is equal to 3. If C is equal to 3, B will be equal to 99, which is 105 minus 2 times 3. And the value of A will be minus 2, because A plus B plus C is equal to 100. So this is not valid. So let us increase C to 4. If C is equal to 4, B will be equal to 97 and A will be equal to minus 1. This also is not valid. So the minimum possible value of C will be equal to 5. In this case, B is equal to 95 and A is equal to 0. This is valid. So the minimum number of people who like all the 3 drinks is 5. And the difference between these two is 52 minus 5, which is equal to 47. In this question, we are told that the average of a non-decreasing sequence of n numbers a1, a2, dot 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 till an is 300. So this would imply that a1 plus a2 plus dot 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 plus an is equal to 300 capital N. We are told that if a1 is replaced by 6a1, the average becomes 400. So 6a1 plus a2 plus dot 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 plus an is equal to 400n. We are required to calculate the number of possible values of a1. If you subtract the first equation from the second equation, we are going to get that 5a1 is equal to 100n, or the value of a1 is equal to 20n. And this sequence of n numbers is non-decreasing, so it is either increasing or constant. So we know that as the average is 300, a1 has to be definitely less than or equal to 300. This would imply that a1 has to be a multiple of 20. So the values that n can take are 1, 2, 3, dot 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 till 50. In the first case, the value of a1 is 20. In the second case, it is 40. Next case, it is 60, dot 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 till 300. But if you do a customary check, you will realize that it is not true for a1 is equal to 20 when n is equal to 1, because in that particular case, the first equation becomes equal to 20 is equal to 300. This is not true. But for every other number, it will be true because there will be more variables. You are not just stuck with a1 and n. For example, if you are looking at n is equal to 2, you have a1 plus a2 is equal to 600. a1 in this case is 40, so 40 plus a2 is equal to 600. You will figure out that a2 is equal to 560. And 6a1 plus a2 will be equal to 400 into 2, which is 800. This will be true when a2 is equal to 560 and a1 is equal to 40, because 6a1 will be 240 and the sum is 800. This is valid for all the remaining values, because in the remaining values you have additional variables. The values of the variables will change such that the equations hold. But in the first case, when n is equal to 1 and a1 is equal to 20, there are only two variables and the equation is not holding. So the correct answer is that n can vary from 2 to 15 and a1 will be 20 times n, so it can take a total of 14 values. In this question, we are told that on day 1 there are 100 particles in an experiment. On day 2, we are told that out of every n article, they produce one article each. So over here on day 2, out of 100, we will have 100 by 2 new articles, which is equal to 50 new articles. So the total number of articles on day 3 will be 150. It has 100 articles from day 1 and 50 articles from day 2. And on day 3, every third article produces a new article. So the number of new articles will be 150 divided by 3, which is again equal to 50. So now the total number of articles will be 150 plus 50, which is 200. And on day 4, the number of new articles that are produced will be 200 divided by 4, which is again equal to 50. So as you can see, every day 50 new articles are coming. So the total number of articles by the end of the nth day will be 100 plus n minus 1 into 50. This will become equal to 1000 when the value of m minus 1 into 50 is equal to 900, or the value of m minus 1 is equal to 18, or the value of m is equal to 19. So the answer for this question is option A. In this question, we are asked to calculate the number of integers which are greater than 2000 that can be formed using the digits 0, 1, 2, 3, 4 and 5, such that each digit is used at most once. Let us first calculate the number of 4-digit numbers that can be formed using these digits which are greater than 2000. Then we will calculate the number of 5-digit numbers, and finally we will calculate the number of 6-digit numbers. If you have a 4-digit number, something like this number has to be greater than 2000. So the first digit can be either 2 or 3 or 4 or 5. So the first digit can be selected in 4 ways. Once the first digit is selected, the remaining 3 numbers can be any number, any digit. The only condition is that it should not be repeated. So the second digit can be selected in 1, 2, 3, 4, 5 ways. There are a total of 6 digits. One of the 4 digits which are greater than 2, greater than or equal to 2 will be used as the first digit. So the second digit can be any one of the remaining 5 digits. The third digit can be any one of the remaining 4 digits which is not equal to the first or the second digit. And the last one can be selected in 3 ways. So the number of 4 digit numbers which are greater than 2000 will be 4 into 5 into 4 into 3, which is 240. If you're looking at the number of 5 digit numbers, every 5 digit number which is formed using these digits will be greater than 2000 because the smallest 5 digit number is 10,000. So the first digit of this 5 digit number can be selected in 5 ways. It can be any number other than 0. It can be either 1 or 2 or 3 or 4 or 5. Once the first digit is selected, we have 5 digits remaining, and any one of those 5 digits can be the second digit. So 2 digits are used now. Any one of the remaining 4 will be the third digit. Any one of the remaining 3 will be the penultimate digit, and any one of the last 2 will be the last digit. So the number of 5 digit numbers which can be formed using 0, 1, 2, 3, 4, 5 is equal to 5 into 5 into 4, which is 100, into 3 into 2, which is 600. Any 5 digit number which is formed using these digits will be greater than 2000. Now if you're looking at 6 digit numbers, again every 6 digit number which is formed using these digits will be greater than 2000. And how many such 6 digit numbers can be formed? Again, the first digit can be selected in 5 ways. Any digit which is not equal to 0, that is 1 or 2 or 3 or 4 or 5. The second digit can be selected in 5 ways. The third digit can be selected in 4 ways. The fourth digit can be selected in 3 ways. This is in 2 ways and this is in 1 way. This is again equal to 600. So the total number of integers which are greater than 2000 that can be formed is 600 plus 600 plus 240, which is 1440. That is option A. In this question, we are told that there is an arithmetic progression 3, 7, 11 and so on. So the first term of this arithmetic progression is 3, and the common difference between consecutive terms is 7 minus 3, which is equal to 4. We know that the sum of the first n terms of an arithmetic progression is given by n by 2 into 2a plus n minus 1 into d. In this particular case, that will be equal to n by 2 into 2a is 6 plus n minus 1 into 4. This is equal to n by 2 into 4n plus 2. This is equal to n into 2n plus 1. That is the value of the sum of the first n terms. In this particular case, we are required to calculate the average of the first 25 sum of the terms. That is, let us first calculate the sum of the first n terms of this n into 2n plus 1. This is equal to 2 times sigma n square plus sigma n. What does sigma n square and sigma n mean? It is very simply the sum of the first n squares of natural numbers, and this will be the sum of the first n natural numbers. We know the formulas for both. The sum of the first n natural numbers, that is 1 plus 2 plus 3 plus dot 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 till n, is equal to n into n plus 1 divided by 2. This is true for all natural numbers. Similarly, the sum of the first n squares of natural numbers, that is 1 square plus 2 square plus 3 square plus dot 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 plus n square, is given by the formula n into n plus 1 into 2n plus 1 divided by 6. So the sum of this for the first n terms will be equal to 2 into sigma n square, which is this, which is n into n plus 1 into 2n plus 1 divided by 6, plus sigma of n, which is this one, which is n into n plus 1 divided by 2. This is the sum of the first 25 terms of this series. We'll have to divide it by 25 again. So if you're substituting that into 1 by 25, and if you're substituting the value of n to be equal to 25, it will simply become equal to 26 into 51 divided by 3 plus 26 divided by 2. This is equal to 26 into 17 plus 13. 26 into 17 is 442 plus 13 is equal to 455. So the answer for this question is option A. In this question, we are told that square root of 7 by 5 to the power 3x minus y is equal to 875 by 2401. If you are trying to simplify 875 divided by 2401, 875 is equal to 7 into 125. And 2401 we know is 7 to the power 4. So this is basically equal to 125 divided by 7 cube, or this is equal to 5 by 7 whole cube. Now square root of 7 by 5 to the power 3x minus y can be simplified to equal 7 by 5 to the power 3x minus y divided by 2. This is equal to 5 by 7 whole cube, or 3x minus y by 2 is equal to minus 3, or the value of 3x minus y is equal to minus 6, or the value of y minus 3x is equal to 6. This is one equation between x and y. If you're looking at the second equation, we are told that for all values of a and b, 4a by b to the power 6x minus y is equal to 2a by b to the power y minus 6x. You'll notice that this is 6x minus y and this is y minus 6x, which is basically a negative value of one another, and this is true for all non-zero values of a and b. This will be true if and only if this power in the exponent is equal to 0, or the value of y has to be equal to 6x. If y is equal to 6x and y minus 3x is equal to 6, it would imply that 3x is equal to 6 or x is equal to 2. If x is equal to 2, y will be equal to 12, which is 6 times x, and x plus y will be equal to 14. If you are wondering why 4a by b to the power 6x minus y, if this is equal to 2a by b to the power y minus 6x, why this should imply that y is equal to 6x, you can bring both of them to the other side. 4a by b to the power 6x minus y into 2a by b to the power 6x minus y, this is equal to 1 for all values of a and b. Clearly you will figure out that this will happen only if 8a square by b square to the power 6x minus y is equal to 1 for all values of a and b. That will happen only if 6x is equal to y. So the answer is x plus y is equal to 14. In this question, we are asked to calculate the arithmetic mean of all the distinct numbers that can be obtained by rearranging the digits of 1, 4, 2, 1, including itself. Now, how many numbers can be found by rearranging the digits of 1, 4, 2, 1? Here we have 4, 2 to be unique numbers and 1 is repeated 2 times. The total number of digits is 4, but like we said, there are 2 1s in it. So the total number of digits that are formed is equal to 4 factorial divided by, because there are 2 1s, 2 factorial. 4 factorial is 4 into 3 into 2 into 1 divided by 2 factorial is 2. This is equal to 12. One way to solve it is actually noting down all the 12 numbers, calculating their total and taking the average, because there are only 12 numbers that can be done. But if the number of digits increases or if the number of alternatives increases, we should know the actual way of solving these kind of questions. So let us try to do that. You have 1, 4, 2, 1. The digits are 1, 2 and 4. These are the unique digits. Now out of these 12 numbers, when you are writing a 4-digit number, how many of them have 1 in the thousands place? If you have 1 in the thousands place, the remaining 3 digits can be either 1 or 2 or 4, because there are 2 1s. So the number of ways in which we can arrange them will be 6. How many will have 2 as the thousands digit? In that case, the remaining 3 numbers have to be 1, 1 and 4. There are total of 3 digits, but 1 is repeated 2 times. So that will be 3 factorial divided by 2 factorial, which is equal to 3. There are 3 such numbers. And how many numbers will have 4 as the thousands digit? Here we will be having 1, 1 and 2. So again we will have 3 such digits, 3 such numbers. Now if you are looking at the sum that is contributed by the thousands digit in all of these 12 cases, 1 is in the thousands place 6 times. So the total sum that is contributed by these 6 numbers from only the thousands place will be 6 into 1000. The total sum that is contributed by these 3 numbers which have 2 in the thousands place will be 3 into 2000. And from the 3 numbers which have 4 in the thousands place will be 3 into 4000. This is equal to 6000 plus 6000 plus 12000, which is equal to 24000. This is if you are looking only at the thousands place. The same way, we will have 6 numbers which will have 1 in the hundreds place. Because the remaining 3 digits have to be 1, 2 and 4 in some order. There are 6 such numbers. We will have 3 numbers which will have 2 in the hundreds place. We will have 3 numbers which will have 4 in the hundreds place. The sum contributed by these numbers which are in the hundreds place, we have just calculated the sum contributed by the thousands place. In the hundreds place, we are going to get 6 into 100 because we'll have 1 in the hundreds place in 6 numbers. 3 into 200, we'll have 3 numbers which will have 2 in the hundreds place, and 3 into 400. We'll have 3 numbers which will have 4 in the hundreds place. This is equal to 2400. This is from the hundreds place. Similarly, in the tens place, we are going to get 240, and in the units place, we are going to get 24. The total sum is just adding all of them up. This is 26400 plus this is 264. This is equal to 2664. This is the total sum of all the 12 numbers. You divide it by 12 to get the average. This will be equal to 2222, which is option A. In this question, we are asked to calculate the average of all the 3-digit terms which are part of the arithmetic progression 38, 55, 72 and so on. Whenever you are asked to calculate the average of an arithmetic progression, the easiest way to calculate the average is to calculate the first term and calculate the last term and take their average. The average of an arithmetic progression is the average of the first term and the last term. This arithmetic progression is 38, 55, 72 and so on. So the difference is 17. So each term of this arithmetic progression is of the form 17 into k plus 4. Because 38 is 34 plus 4. 34 is a multiple of 17. Then you add 17 to it. 55 will come. 55 is 51 plus 4. Then you get 72. 72 is 68 plus 4. So every term is of the form 17k plus 4. What is the smallest 3-digit number which is part of this arithmetic progression? The smallest 3-digit number will be, the smallest multiple of 17 is 102. So the smallest multiple will be 106. So we'll have 106 in it, then we'll have 123 in it, then we'll have 140 in it and so on. What is the largest 3-digit number which will be part of this arithmetic progression? The easiest way to calculate it is find out a multiple of 17, which is close to 1000. The first thing that comes to mind is 17 into 60, which is 1020. So one number which is part of this arithmetic progression will be 1024, but this is a 4-digit number. So we'll remove 17 from it. We'll have 1007. This also is a 4-digit number. We'll remove another 17 from it. So the last 3-digit number will be 990. So the arithmetic progression, which has only 3 digits, will be 106, 123, 140, till 990. The average of this arithmetic progression is the average of the first term and the last term, which will be equal to 106 plus 990 divided by 2. This is equal to 1096 divided by 2, which is equal to 548. So the answer for this question is 548.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, XAT, SNAP, MAT, CMAT, TEST and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, we are asked to calculate the number of 3 or more distinct numbers that can be chosen out of a group of 8 numbers. They are 1, 2, 3, 4, 5, 6, 7 or 8. And out of these 8, we should select 3 or more numbers. But we have some conditions involved. 3 and 5 should always be included, and 7 and 8 should not be included together. So if you're looking at the numbers, 3 and 5 are definitely part of it. So we don't have any choice with respect to 3 and 5. They have to definitely be included. So the only choice that we have is with respect to the remaining 6 numbers. And out of these 6 numbers, we should select at least 1 or more, because 3 and 5 are already selected. Now the only condition that is left is with respect to 7 and 8. Both 7 and 8 should not be selected together. So now let us consider 3 cases. In the first case, only 7 is selected and not 8. In the second case, only 8 is selected and not 7. And in the last case, neither 7 nor 8 is selected. These are the 3 cases to consider. If only 7 is selected, then we already have 3 numbers that are selected. 3 and 5 are already there and 7 is already included. 8 is not included. So we have a lot of choice with respect to 1, 2, 4 and 6. Each of these 4 numbers can either be selected or not selected. So the number of ways in which we can pick in this particular case will be 2. This is the number of ways in which 1 can be decided. It can either be selected or not selected. Into 2, same with the number 2. Into 2, same with the number 4. Into 2, same with the number 6. So there are a total of 16 cases. Similarly, in the case where 8 is selected and not 7. Now we have 3 and 5 already and we have 8. So the minimum of 3 numbers is already qualified and we have to make the choice about 1, 2, 4 and 6 again. And the total number of ways in which this can be done is again 2 to the power 4, which is 16. Each of the number can either be selected or not selected. So each of the number has 2 choices. So the overall choice is 16. Now let us assume that 7 is not selected and 8 is not selected. We have only 2 numbers, 3 and 5. So we have to select at least 1 out of 1, 2, 4 and 6. So the number of ways this can be done is again 2 to the power 4 minus 1. So for each of the numbers again we have a case, either 1 can be selected or not selected, that is 2 ways. Either 2 can be selected or not selected, another 2 ways. Either 4 can be selected or not selected, again 2 ways. Either 6 can be selected or not selected. So the total is 16. But the one case where neither 4 of them is selected has to be subtracted, because in that case only 3 and 5 are selected and the total number of numbers selected will be only 2. We need at least 3 numbers to be selected. So out of this 16, we will be removing one particular case, so we will be left with 15 subcases. So the total number of ways in which 3 or more numbers can be selected out of the given 8 numbers, such that 3 and 5 are always selected and only one of, at most one of 7 and 8 is selected, is 16 plus 16 plus 15, which is equal to 47. In this question, we are asked to find out how many 3-digit numbers are greater than 100 and increase by 198 when the 3 digits are reversed. Let us assume that the 3-digit number is A, B and C, where A is in the hundreds place, B is in the tens place and C is in the units place. So the value of this 3-digit number will be equal to 100A plus 10B plus C. For example, if the 3-digit number is say 243, the value of 243 is 2 into 100, that is 200, plus 4 into 10, that is 40, plus 3 into 1, that is 3. So this is 200 plus 40 plus 3. When the digits are reversed, it becomes equal to CBA, and the value becomes equal to 100C plus 10B plus A, or the increase in the value is equal to 100C plus 10B plus A minus 100A plus 10B plus C, which is equal to 99C minus 99A. This we are told is equal to 198. If you divide both sides with 99, we are going to get that C minus A is equal to 2, or the value of C is equal to A plus 2. We are told that the 3-digit number is greater than 100. So the value of A is greater than 1, greater than or equal to 1. So what are the values that A can take? If A is equal to 1, C is equal to 3. If A is equal to 2, C is equal to 4. If A is equal to 3, C is equal to 5. If A is equal to 4, C is equal to 6. If A is equal to 5, C is equal to 7. If A is equal to 6, C is equal to 8. And if A is equal to 7, C is equal to 9. We want the 3 numbers A, B and C to be strictly less than 10, because they are single digit numbers. So the values that A can take are 7. For each value that A is taking, C has exactly one value. That is, when you fix the value of A, C has to be equal to A plus 2. Now what will B take? B can take any value. There is no restriction on B. B can be either 0 or 1 or 2 or dot 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 till 9 in each of these cases. So the number of values that B can take is 10. So the total number of such numbers is 7 into 10, which is equal to 70. This will be the answer. In this question, we are told that 5 minus log of square root of 1 plus x plus 4 times log of square root of 1 minus x is equal to log of 1 by square root of 1 minus x square. The first thing to notice is that we want 1 plus x to be greater than 0. Otherwise, square root is not defined. Similarly, we want 1 minus x to be greater than 0. So this would imply that x has to lie between minus 1 and plus 1. The second thing we should notice is that the right hand side is log of 1 by square root of 1 minus x square. Log of 1 by square root of 1 minus x square is equal to minus of log of square root of 1 minus x square. But what is 1 minus x square? 1 minus x square is 1 minus x into 1 plus x. So this is equal to minus of log of square root of 1 minus x plus log of square root of 1 plus x. This is basically the right hand side. If you are inserting this in the equation, the left hand side remains the same. This is 5 minus log of square root of 1 plus x plus 4 times log of square root of 1 minus x is equal to minus of log of square root of 1 minus x minus of log of square root of 1 plus x. This is the simplified format of the right hand side. We can cancel minus of log of square root of 1 plus x on both sides. This would imply that 5 times log of square root of 1 minus x is equal to minus 5, or the value of log of square root of 1 minus x to the base 10 is equal to minus 1. Earlier we did not include the base because all the bases were the same and they are equal to 10. So this would imply that square root of 1 minus x is equal to 10 to the power minus 1, which is equal to 1 by 10. Or the value of 1 minus x is equal to 1 by 100. Or the value of x is equal to 99 by 100. So the value of 100x will be equal to 99.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
In this question, we are told that x0 is equal to 1, x1 is equal to 2, and a formula is given to calculate the next number in the series. X of n plus 2 is equal to 1 plus x of n plus 1 divided by x of n. We know x0, this is equal to 1. We know x1, this is equal to 2. So the value of x2 will be equal to 1 plus 2 divided by 1, which is equal to 3. And the value of x3 will be equal to 1 plus 3 divided by 2, which is equal to 2. And the value of x4 is equal to 1 plus 2 divided by 3, which is equal to 1. Similarly, the value of x5 will be equal to 1 plus 1 divided by 2, which is equal to 1. And the value of x6 will be equal to 1 plus 1 divided by 1, which is equal to 2. And x7 is equal to 1 plus 2 divided by 1, which is equal to 3, and so on. So if you look at the pattern is that it is 1, 2, 3, 2, 1. So you have 1, 2, 3, 2, 1. This is x0, this is x1, this is x2, this is x3, this is x4. Then you have again 1, 2, 3, and you are going to get another 2, 1. So again you will have 1, 2, 3, 2, 1. This will be x5, this is x6, this is x7, this is x8, and this is x9, and so on. The pattern is repeating. So whenever you are getting a multiple of 5, it will the cycle is going to start at 1. You are asked to calculate the value of x of 2021. So x of 2020, which is a multiple of 5, will be over here, and that will equal 1, and x of 2021 will be 2. So the correct answer in this particular case is option D, which is equal to 2. In this question, we are told that natural numbers are divided into groups. The first group has only 1, the second group has 2, 3, and 4, the third group has 5, 6, 7, 8, and 9, and so on. If you are looking at the groups, you would notice that the last number of the nth group is n square. The last number in the first group is 1, the last number in the second group is 4, the last number in the third group is 9, and so on. So what is the last number of the 15th group? The last number of the 15th group will be 225. And what is the last number of the 14th group? The last number of the 14th group will be equal to 196. So if you are calculating the sum of all the numbers in the 15th group, we have to essentially calculate the sum of 197 plus 198 plus dot 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 till 225. This is an arithmetic progression. We know the first term and the last term, and the number of terms over here will be 29. There are 29 such numbers if you are including 197 and 225. So the sum of these numbers will be the sum of the first number plus last number divided by 2 into the number of numbers. If you are given an arithmetic progression, if you know the number of terms, if the number of terms is n, if you know the first term, if it is equal to f, and if you know the last term, if it is equal to L, the sum of the arithmetic progression is n into f plus L divided by 2. Here the number of terms is 29, the first term is 197, the last term is 225, so you divide it by 2. This is equal to 29 into 422 divided by 2. This is 29 into 211. This can be simplified to equal 6119. That will be the answer. In this question, we are told that there are three positive integers x, y, and z. They are in an arithmetic progression. Let us assume that the common difference of the arithmetic progression is d. So the first term of the arithmetic progression is x, the second term is x plus d, which is equal to y, and the third term will be x plus 2d. All of them are positive integers, so this would imply that as x is a positive integer, d also is an integer. We are told that y minus x is greater than 2, so this would imply that d is greater than 2, because y is equal to x plus d, so y minus x is equal to d, so the value of d has to be greater than 2 and d is an integer. We are given an equation, we are told that x into y into z is equal to 5 times x plus y plus z. What is the value of the left hand side? That will be x into x plus d into x plus 2d. And what is the value of x plus y plus z? That will be 3x plus 3d. So this is equal to 5 times x plus y plus z will be 3x plus 3d. So this is 5 into 3 into x plus d. You can cancel x plus d on both sides. So this would imply that x into x plus 2d is equal to 15. We know that x is an integer and x plus 2d is also an integer. Both of them are positive integers. So both of them have to be factors of 15. In how many ways can we express 15 as a product of two positive numbers? We have only two ways. It is either 1 into 15 or it is 3 into 5. Now the difference between these two, that is the difference between x and x plus 2d will be equal to 2d. And we know that d is greater than 2. So this would imply that the difference between these two numbers has to be greater than 4. So the second one doesn't add up. If you assume that x is equal to 3 and x plus 2d is equal to 5, the value of 2d will be equal to 2 or the value of d is equal to 1, which is a contradiction. So the second one is not allowed. So only the first set of numbers is allowed. So this would imply that x is equal to 1, x plus 2d is equal to 15, or the value of 2d is equal to 14. So the value of d is equal to 7. What we are required to calculate is the value of z minus x. Z is x plus 2d. So z minus x will be equal to 2d and the value of 2d is equal to 14. So the correct answer is 14. In this question we are told that there are 15 identical balloons, 6 identical pencils and 3 identical erasers, and they have to be distributed amongst 3 children, such that every child gets at least 4 balloons and 1 pencil. Now because there are 3 children and each one of them at least has to get 4 pencils, let us first distribute 4 pencils, that is 12 pencils amongst these 3 children. We'll first remove those 12 pencils. Similarly, we'll 12 balloons amongst these 3 children, and we'll also remove 3 pencils because every child has to get 1 pencil. Now remember that these are identical balloons and identical pencils. So which 12 balloons we are choosing doesn't make sense. And which balloon are we giving to any one of these 3 children? Again, we have no choice because all of these pencils and balloons individually look the same. So if you are removing this, there will be one child over here, one child over here, and one child over here. We have given each one of them 4 balloons and we have given 1 pencil. This is something that we have to do, and once we have distributed this, how many pencils and balloons are left with us? We are left with 3 balloons because 12 balloons are distributed. We are left with 3 pencils because 3 pencils are distributed, and we are left with 3 erasers. Now each one of them are 3 individual events. How we distribute these 3 balloons amongst these 3 children? There is no restriction. Now any child can get all the 3 balloons, any child can get 0 of the 3 balloons because we have distributed 4 balloons earlier. Similarly, how we distribute the 3 pencils is also completely up to us, and how we distribute the 3 erasers is also completely up to us. Let us first look at the 3 balloons. Now let us assume that amongst these 3 balloons, the first child gets C1 balloons, the second child gets C2, and the third child gets C3. They've already gotten 4, 4, 4. This C1 and C2 and C3 is in addition to the 4 balloons that they have originally received. So C1 plus C2 plus C3 has to equal 3. Now how many solutions does this equation have? We know that if you have an equation which is of the form x1 plus x2 plus dot 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 plus xr, and this equals n, the number of non-negative integral solutions, that is the number of ways in which we can satisfy this equation such that all of these numbers x1, x2, x3, all of them are whole numbers, that is their integers greater than or equal to 0, is equal to n plus r minus 1 c r minus 1. So in this particular case, the number of solutions for this particular equation will be 3 plus 3 minus 1 c 3 minus 1. This is equal to 5c2, which is equal to 10. So we can distribute these 3 balloons amongst these 3 children in 10 ways. In the same way, we can distribute the 3 pencils amongst these 3 balloons in 10 ways. And we can distribute the 3 erasers amongst these 3 children in 10 ways. So the total number of ways of distributing is 10 into 10 into 10, which is 1000. This will be the answer. In this question, we are given an equation. We are told that log of 3 plus log of 4 plus log of x minus 1, their different bases, is minus 2 is equal to 0. And we are asked to calculate the value of 4x. If you are looking at the equation, log of the base is 2, 3 plus log of, now the base is 3, 4 plus log of the base is 4 into x minus 1, this is the argument, minus 2 is equal to 0, this is equal to 2. If you are removing the outermost log and if you are transferring the base over here, this will be 2 to the power 2, which is equal to 4. That is the value of 3 plus log of all of this. So if you are subtracting 3 from both sides, this will become equal to 1. So log of 4 plus log of x minus 1, the first base is 4 over here and the second base is 3, is equal to 1. If you are now removing this logarithm and if you are transferring 3 to the other side, the right hand side becomes equal to 3 to the power 1, which is equal to 3. Now we will subtract 4 from both sides because now we have 4 plus this. So if you are subtracting 4, this becomes equal to minus 1. Just to write it in a new line, we have log of the base is 4, x minus 1 is equal to minus 1. Now if you are removing the outermost logarithm over here and if you are transferring 4 to the other side, the right hand side becomes equal to 4 to the power minus 1, which is equal to 1 by 4. That is, the value of x minus 1 is equal to 1 by 4, or the value of x is equal to 5 by 4. So the value of 4x will be equal to 5. So the correct answer for this question is that the value of 4x is equal to 5. In this question, we are given a sequence of real numbers and we have been given an equation which all of them satisfy. We are told that x1 minus x2 plus x3 minus dot dot dot, where the sign is alternating, is equal to n square plus 2n. We are asked to calculate the value of x49 plus x50. If you are looking for x49, let us first write down x1 minus x2 plus x3 dot dot dot. The sign before the odd numbers is positive, the sign before the even numbers is negative. So minus x48 plus x49 is equal to 49 square plus 2 times 49. If you are trying to calculate the value of x49, we will write down the same equation, but here the last term will be minus x48. This will be equal to 48 square plus 2 times 48. Now if you subtract the second equation from the first equation, the first 48 terms get cancelled and you are left with x49. This is equal to 49 square minus 48 square plus 2 times 49 into 2 minus 2 times 48. 49 square minus 48 square can be easily calculated because this is of the form x square minus y square, which is equal to x minus y into x plus y. So this is 49 minus 48 into 49 plus 48 plus 2 times 49 minus 2 times 48 will be 2. So this is equal to 97 plus 2, which is 99. That is the value of x49. Similarly, we will calculate the value of x50. So for that we will write down the same equation, but here we will make the last term to be x50. So we have x minus x48 plus x49 minus x50 is equal to 50 square plus 2 times 50. Now if you subtract the first equation from the third equation, you will be left on the left hand side with minus x50. This is equal to 50 square minus 49 square plus 2 times 50 minus 2 times 49. 50 square minus 49 square, again because this is of the form x square minus y square, is equal to 50 minus 49 into 50 plus 49. So that will equal 99 plus 2 times 50 minus 2 times 49 is 2. So this is equal to 101. But what is 101? 101 is minus x times x50. So the value of x50 will be minus 101. Now we are asked to calculate x49, which is 99, plus x50, which is minus 101. 99 minus 101 will be minus 2. So the required answer for this question is option D. In this question, we are told that log of a to the base 15 plus log of a to the base 32 divided by log of a to the base 15 into log of a to the base 32 is equal to 4. And we are asked to find out the interval in which a is going to lie. If you are first cross multiplying, you are given that log of a to the base 15 plus log of a to the base 32 is equal to 4 times log of a to the base 15 into log of a to the base 32. We know that log of a to the base 15 is basically equal to log of a divided by log of 15 plus log of a divided by log of 32. This is equal to 4 times log of a divided by log of 15 into log of a divided by log of 32. We can cancel one log of a from the left hand side and right hand side, and now again multiply both sides with log of 15 into log of 32. So the left hand side becomes equal to log of 32 plus log of 15 is equal to 4 times log of a, or log of 480, which is 32 into 15, is equal to log of a to the power 4. We can cancel logs on both sides. So a to the power 4 is equal to 480. We can calculate the exact value of a, but essentially what we are asked to find out is whether a lies between 2 and 3, or whether it lies between 3 and 4, or 4 and 5, or whether it is greater than 5. That is the options that are given to us. We know that 4 to the power 4 is 256 and 5 to the power 4 is 625. 480 lies somewhere in the middle of 256 and 625. So a to the power 4, which is equal to 480, would imply that a lies between 4 and 5. So the correct answer is option C. In this question, we are given a sequence of numbers x1, x2, dot, dot, dot. We are told that x1 is equal to minus 1 and x of n plus 1 is equal to xn plus n minus 1. So we know that x1 is equal to minus 1. We know that x2 is equal to x1 plus 0, because that is plus 1 minus 1. x3 is equal to x2 plus 2 minus 1, which is equal to 1. x4 is equal to x3 plus 3 minus 1, so that is 2. Similarly, this will continue. We are required to calculate the value of x100. X of 100 is equal to x of 99 plus 99 minus 1, so that is 98. If you are adding the left hand side, it will be x1 plus x2 plus dot 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 till x100. This is equal to x1 plus x2 plus dot 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 till x99 plus 0, 1, 2 dot 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 till 98, that is 1 plus 2 plus dot 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 till 98 minus the original 1. The reason we write it this way is because then we can cancel x1 to x99 on both sides, and the value of x100 will be equal to 1 plus 2 plus dot 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 till 98 minus 1. What is the sum of the first 98 natural numbers? The sum of the first n natural numbers, that is 1 plus 2 plus dot 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 till n, is equal to n into n plus 1 divided by 2. In this particular case, that will be 98 into 99 divided by 2 minus 1. 98 by 2 is 49. So this is 49 into 99 minus 1. 49 into 99 is 4851. So this is 4851 minus 1, which is 4850. So the correct answer is option D. In this question, we are told that there is a 4-digit number which is formed using the digits 1, 2 and 3 such that 2 and 3 have to appear at least once. And we are required to calculate how many such 4-digit numbers exist. Before we actually do that, let us first look at a particular instance where say there are only two alphabets A and B, and A is repeated say 3 times. Then the number of combinations of the words that can be formed using 3 A's and 1 B will be equal to 4 factorial divided by, because A is repeated 3 times, 3 factorial, which is equal to 4. And those 4 numbers basically will be AAAAB or AABA or ABAA or BAAA. Similarly, if you are having 4 alphabets such that A is repeated 2 times and B is repeated 2 times, then the number of words that can be formed is 4 factorial divided by, because A is repeated 2 times, 2 factorial, and B is repeated 2 times, so another 2 factorial, which will be equal to 6. In general, if you have n total number of alphabets to be n, suppose they are x1, x2 dot 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 into xn, but some of them are the same. Suppose these contain say A 4 times and suppose B is repeated 3 times. That is basically say if x1 is A, x2 is A, x3 is A, x4 is A, and so on. Similarly, you have 3 B's and suppose you have some more C's and so on. Then the total number of permutations of words that can be formed will be equal to n factorial, which is the total number of alphabets, divided by, for each instance, the number of times that particular alphabet is repeated. So in this case, A is repeated 4 times, so you divide n factorial by 4 factorial. B is repeated 3 times, so by 3 factorial, and so on. If suppose there is an alphabet which is not repeated, but it will be repeated only once, that is say there is an alphabet D which is existing only once, then you divide it by 1 factorial, but that is redundant because 1 factorial is 1. In general, if you are having all the n letters to be distinct, then the number of permutations that are possible is n factorial. But if say a particular alphabet is repeated 2 times, then you divide it by 2 factorial. If another alphabet is also repeated 2 times, then you again divide it by 2 factorial, and so on. For example, in this particular case, because we are having 2 A's and 2 B's, it is 4 factorial divided by 2 factorial and another 2 factorial. 4 factorial is 24, 2 factorial is 2, 2 factorial is 2, so that is 24 divided by 4, which is 6. Now, if you are looking at this particular question, we have to find a 4-digit number using 1, 2 and 3, and 2 and 3 have to be repeated at least once. So let us first consider the case where there is no 1. There will be 2 such cases. You will have 3 2's and 1 3, or you will have 2 2's and 2 3's, or you will have another case actually. You will have 1 2 and 3 3's. These are all the cases possible without having a single 1. Suppose you are having only 1. Now you can have either 1 2 and 2 3's, or you can have 2 2's and 1 3. Suppose you are having 2 1's, this is 1 and this is 1. Then there is only one case possible because 2 and 3 have to appear at least once. These are all the cases that are possible, but in each particular case we have a different number of permutations. In the first case, there are again always 4 digits, but 2 is repeated 3 times. So it has to be 4 factorial divided by 3 factorial, which is 4. 4 permutations are possible. In the second case, you have 2 2's and 2 3's. So the total number of permutations possible is 4 factorial divided by 2 factorial into 2 factorial, which is 6. In the third case, you have 3 3's and 1 2. So again, it is the first instance. So it will be 4. Now you have 2 3 3 1. So again, it has to be 4 factorial divided by 2 factorial because only 3 is repeated 2 times. 4 factorial divided by 2 factorial will be equal to 12. So this will be 12. In this particular case, again 1 and 3 are distinct, they are not repeated, but 2 is repeated 2 times. So again it will be 4 factorial divided by 2 factorial, which is 12. In the last case also, 2 and 3 appear only once, but 1 is repeated 2 times. So again it will be 4 factorial divided by 2 factorial, which is 12. So the total number of numbers that can be formed will be 12 plus 12 plus 12, which is 36, plus 4, so 40, plus 6 plus 4 is 10, 40 plus 10 is 50. So the required answer is 50. In this question, we are told that 2 to the power y square into log of 5 to the base 3 is equal to 5 to the power log 3 to the base 2, and we are asked to find out the value of y. So if you're looking at it, this is of the form 2 to the power y square into a is equal to 5 to the power b, or this would imply that 2 to the power y square is equal to 5 to the power b by a, or again this would imply that y square is equal to log of 5 to the power b by a to the base 2. Or to simplify this, this will equal b by a into log of 5 to the base 2. What is the value of b? b is the power of 5, which is equal to log 3 to the base 2. And what is the value of a? a will equal log 5 to the base 3. Or essentially y square is equal to b, so that is log of 3 to the base 2 divided by a, which is log of 5 to the base 3 into log of 5 to the base 2. We can simplify each one of these terms, because log 3 to the base 2 is equal to log of 3 divided by log of 2, and log of 5 to the base 3 is equal to log 5 divided by log 3, but because it is in the denominator it will be reversed, and so this will become equal to log 3 divided by log 5, and log 5 to the base 2 will equal log of 5 divided by log of 2. We can cancel log 5 in the numerator and denominator, and so the numerator will become equal to log 3 into log 3, which is log 3 whole square, and log 2 into log 2, which is again the denominator is log 2 whole square, or the right hand side will become equal to log of 3 by log of 2 whole square. This is equal to y square, or the value of y will equal minus log of 3 by log 2. Remember that y is a negative number, so we can ignore the term log 3 by log 2, it will only be minus of that. So this will equal minus of log 3 by log 2, which is equal to minus 1 into log of 3 to the base 2, or this is equal to log of 1 by 3 to the base 2, which is option B. In this question we are told that x is equal to 4096 to the power 7 plus 4 square root of 3, and we are asked to find out what is the value of 64. One other thing that you should notice is that 64 square is equal to 4096. So let us try to express x in terms of 4096. So 4096 will become equal to x to the power 1 by 7 plus 4 square root of 3. But if you are looking at the term 1 divided by 7 plus 4 square root of 3, if you multiply the numerator and denominator with 7 minus 4 square root of 3, the denominator, that is 7 plus 4 square root of 3 into 7 minus 4 square root of 3, will become equal to 7 square minus 4 square root of 3 whole square. 7 square is equal to 49 and 4 square is 16 into 3 is equal to 48. So this becomes equal to 1, or the denominator is equal to 1. So the value of 1 by 7 plus 4 square root of 3 is equal to 7 minus 4 square root of 3. So the value of 4096 is equal to x to the power 7 minus 4 square root of 3. We are asked to find out the value of 64. So 64, which is equal to square root of 4096, will equal x to the power 7 minus 4 square root of 3 divided by 2, or this is equal to x to the power 7 by 2 whole divided by x to the power 4 square root of 3 divided by 2, which is equal to 2 square root of 3. So that will be option C. In this question we are told that log of 5 to the base 4 is equal to log of y to the base 4 into log of square root of 5 to the base 6, and we are asked to find out the value of y. So if you are looking at the left hand side, log of 5 to the base 4 is equal to log of 5 divided by log of 4, and the right hand side is equal to log of y to the base 4, which is equal to log of y divided by log of 4 into log of square root of 5 to the base 6. Log of square root of 5 to the base 6 is equal to half log of 5 to the base 6. So this will be equal to into half into log of 5 divided by log of 6. We can cancel the common terms on the left hand side and right hand side. For example, log 5 is common in the numerator on the left hand side and right hand side, and log 4 is common to the denominators. So log of y is equal to 2 log of 6. 2 log of 6 is equal to log of 6 square, which is equal to log of 36. So we can cancel log on both sides, so the value of y will equal 36.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, ZAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, we are told that x of 1 is equal to minus 1 and x of m is equal to x of m plus 1 plus m plus 1 for every positive integer m, and we are required to calculate the value of x of 100. So if you are looking at x of 1, it is given to be equal to minus 1. We are also told that x of m plus 1 is equal to x of m minus m plus 1 for every integer m. We have just calculated the value of x of m plus 1 in terms of x of m using the given equation. So x of 2, for example, will be equal to x of 1 minus 2. As x of 1 is equal to minus 1, this will equal minus 1 minus 2, or this will equal minus of 1 plus 2. Similarly, the value of x of 3 will be equal to x of 2 minus 3, which is equal to minus 1 minus 2 minus 3, which is equal to minus of 1 plus 2 plus 3. You can find a pattern. Similarly, the value of x of 100 will be equal to minus of 1 plus 2 plus 3 plus dot 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 till 100. This is minus of the sum of the first 100 natural numbers. We know that the sum of the first n natural numbers, that is the value of 1 plus 2 plus 3 plus dot 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 till n, is equal to n into n plus 1 divided by 2. So what is the sum of the first 100 natural numbers? That will be equal to 100 into 101 divided by 2. 100 divided by 2 is 50, and 101 into 50 is equal to 5050. So the value of x of 100 will be minus of that, or it will equal minus 5050. This is the answer. In this question, we are told that log of 30 to the base a, small a is equal to capital A, and log of 5 by 3 to the base small a is equal to minus b. We are also told that log of a to the base 2 is equal to 1 by 3, and we are required to find out the value of log of a to the base 3. So if you look at the information that is given to us, we are given log of 30 to the base a, we are given log of 5 by 3 to the base a, and we are given log of a to the base 2. So what we will first try to calculate is log of 3 to the base a. Once we calculate log of 3 to the base a, we can easily calculate log of a to the base 3 by just taking the reciprocal. So if you are looking at the first two equations that are given to us, log of 30 to the base a is given as equal to capital A, and log of 5 by 3 to the base small a is given to be equal to minus b. This is minus b. Let us first add both the equations so that the left hand side becomes equal to log of 30 to the base small a into 5 by 3 is equal to a minus b. This is just addition of both the logarithms on the left hand side and adding a to minus b. So the left hand side becomes equal to log of 50 to the base small a is equal to a minus b. Log of 50 is equal to 25 into 2. 25 is 5 square. So the left hand side becomes equal to 2 log of 5 to the base a plus log of 2 to the base a is equal to a minus b. We know that log of a to the base 2 is equal to 1 by 3. So the value of log 2 to the base a will be the exact reciprocal. So that will equal 3. So 2 log 5 to the base a plus 3 is equal to a minus b, or the value of log of 5 to the base a is equal to a minus b minus 3 whole divided by 2. Now why did we calculate the value of log 5 to the base a? Because if you are looking at the second equation, we are given log of 5 by 3 to the base a. So that would imply that the second equation would be log of 5 to the base a minus log of 3 to the base a is equal to minus b. Or the value of log of 3 to the base a is equal to log of 5 to the base a plus b. Log of 5 to the base a is equal to a minus b minus 3 by 2. So if you are adding b to it, it will become equal to a minus b minus 3 by 2 plus b, which will equal a plus b minus 3 divided by 2. This is the value of log of 3 to the base a, but we are asked to find out the value of log of a to the base 3. So that, as we have discussed earlier, will be the exact reciprocal, and that will equal 2 divided by a plus b minus 3. So the correct answer is option A. In this question, we are given an equation. We are told that 14 to the power of a is equal to 36 to the power b is equal to 84 to the power c. So 14 to the power a is equal to 36 to the power b is equal to 84 to the power c. Let us assume that all of them are equal to a constant k. So the value of a will be equal to logarithm of k to the base 14. Similarly, b is equal to logarithm of k to the base 36, and c is equal to logarithm of k to the base 84. We are asked to find out the value of 6 into b into 1 by c minus 1 by a. What is the value of 1 by c? 1 by c, because c is equal to log k to the base 84, 1 by c will be equal to log of 84 to the base k. Similarly, 1 by a will become equal to log of 14 to the base k. So if you are subtracting 1 by a from 1 by c, the value of 1 by c minus 1 by a will become equal to logarithm of 84 to the base k minus logarithm of 14 to the base k. Note that both the base of the logarithms are the same. So this will be equal to 84 divided by 14, that is equal to 6 log of 6 to the base k. Now if you are multiplying this with b, so if you do b into 1 by c minus 1 by a, you have to multiply log of 6 to the base k into b, which is equal to log k to the base 36. Log 6 to the base k is equal to log of 6 divided by log of k into log of k to the base 36 is equal to log of k divided by log of 36. You can cancel log of k in the numerator and denominator. So this becomes equal to log of 6 divided by log of 36. Log of 36, because 36 is equal to 6 square, will become equal to 2 times log of 6. That is the value of log of 36. Now again you can cancel log 6 in the numerator and denominator, or the value of b into 1 by c minus 1 by a will equal exactly half. What we are supposed to calculate is 6 times that. So if you multiply both the sides with 6, the resultant value will be equal to 6 into half, which is equal to 3. So the value of the required expression will be equal to 3. In this question, we are given an expression and we are asked to simplify it. The numerator is simple. The numerator is 2 into 4 into 8 into 16. So let us first look at the denominator, which looks slightly more complex. So if you are looking only at the denominator, that is equal to log 4 to the base 2 whole square. The value of log 4 to the base 2 is 2. So this is equal to 2 square into log of 8 to the base 4 whole cube. What is the value of log 8 to the base 4? Because both of them are powers of 2, we can represent 8 as 2 cube and 4 as 2 square. We should also remember one formula, which is that log of x to the power m to the base y is equal to m into log of x to the base y. This is if m is the power of the argument, but if it is the power of the base, that is log of x to the base y to the power m, it will become equal to 1 by m into log of x to the base y. These are standard formulas for logarithms. So if you apply that to simplify the value of log 8 to the base 4, 8 is equal to 2 cube. So this will be 3 in the numerator, and 4 is equal to 2 square. So 2 will be in the denominator into log of 2 to the base 2, which is equal to 1. So log of 8 to the base 4 is equal to 3 by 2. We need log of 8 to the base 4 whole cube. So this will be 3 by 2 whole cube into log of 16 to the base 8. For a similar reason, using the same formula, log of 16 to the base 8 will equal 4 by 3, because 16 is 2 to the power 4 and 8 is 2 cube. So we need log of 16 to the base 8 whole to the power 4. So this will be into 4 by 3 whole to the power 4. Let us simplify this. So this will equal 2 into 2 into 3 into 3 into 3 divided by 2 into 2 into 2 into 4 by 3 to the power 4. So we will have 4 4s in the numerator and we will have 4 3s in the denominator. We can simplify this, we can cancel the common terms, we can cancel all these 3s over here and we can cancel 4 and make it 2. So that will be 4 cube, which is 64 into 2, 128 divided by 3. This is the value of the denominator. So if you are trying to find out the value of the expression, it will be equal to 2 into 4 into 8 into 16 divided by 128 divided by 3. So the 3 will come to the numerator. You can cancel 16 into 8, which is equal to 128 in the numerator and denominator. So the answer will be equal to 2 into 4, which is 8 into 3, which is equal to 24. So this is the answer. In this question, we are told that 1 is less than a, which itself is less than or equal to b, and we are given an expression and we are asked to find out which of the 4 given options cannot be the value of the given expression. If you are looking at the expression, it will equal log of a by b to the base a plus log of b by a to the base b. What is the value of log of a by b to the base a? If you expand it, this will become equal to log of a to the base a minus log of b to the base a. And the value of log of b by a to the base b will become equal to log of b to the base b minus log of a by a to the base b. Log of a to the base a and log of b to the base b will equal 1. So this is 1 and this is equal to 1. And the value of, if you assume that the value of log b to the base a is equal to y, then the value of log of a to the base b will equal 1 by y. So the given expression is of the form 1 minus y plus 1 minus 1 by y. Now this is equal to 2 minus y plus 1 by y. We are told that both a and b are greater than 1. So the value of y and 1 by y, both of them are greater than equal to 0. Greater than 0. So if both of them are greater than 0, then the value of y plus 1 by y will always be greater than or equal to 2. This you are going to get by using the arithmetic mean is greater than or equal to geometric mean theorem. Y plus 1 by y divided by 2, which is the arithmetic mean of y and 1 by y, is greater than or equal to square root of y into 1 by y. This is equal to 1, or the value of y plus 1 by y is always greater than or equal to 2. So the given expression, which is 2 minus of y plus 1 by y, is always less than or equal to 0. If you are looking at the options, option A is possible because this given expression can equal 0, and option B and D, both of them are negative, so that is also possible. The only value which is not possible is option C, which is a positive number. In this question, it is told that students in a college have to choose at least 2 subjects from chemistry, maths and physics. We are told that the number of students who are choosing all the 3 subjects is 18, and we are also given some information about the number of students who chose mathematics and the number of students who chose physics. So clearly this is a Venn diagrams question because there is an overlap between the different parameters or the different subjects that a student can choose. So let us draw 3 circles. Each of this circle will represent the number of students who like a particular subject. So let us assume that this is mathematics, this is chemistry, and this is a physics. We are told that each of the student likes at least 2 subjects. So the number of students who like only maths is 0, the number of students who like only chemistry and only physics is also 0. 18 students like all the 3 subjects. So the overlap in the middle will be equal to 18. We are told that the number of students who like mathematics is 23. So if you assume that the number of students who like maths and chemistry but not physics is equal to A, the number of students who like maths and physics but not chemistry will have to equal 23 minus 18 plus A. So this will equal 5 minus A. So the number of students who like only mathematics and physics is equal to 5 minus A. We are also told that the number of students who like only physics is 25. So if you are trying to identify the number of students who like chemistry and physics but not maths, that will equal 25 minus 18 plus A. This will be the number of students who like maths and physics but not chemistry, plus the number of students who like all the 3 subjects, plus the number of students who like chemistry and physics but not maths. The sum of these 3 should equal 25. So if you assume that this is equal to say x, then 5 minus A plus 18 plus x is equal to 25, or you can calculate the value of x to be equal to A plus 2. So just for ease, let us remove this and write A plus 2 over here. Now what are the different values that A can take? You want all the numbers in each of these areas to be greater than or equal to 0, because you don't have negative human beings. So A has to be greater than or equal to 0, A plus 2 also has to be greater than or equal to 0, and 5 minus A also has to be greater than or equal to 0, or A itself has to be less than or equal to 5. So the value of A will vary from 0 to 5, both of them included. And we are asked to find out the smallest possible number of students who could choose chemistry as one of their subjects. If you are calculating the sum of all the areas which are included in the circle of chemistry, that will be equal to A plus 18 plus A plus 2. This is the total number of students who like chemistry as one of the subjects. So that will be equal to 20 plus 2A, and you are trying to find out the minimum possible value of 20 plus 2A. You know that the minimum possible value of A is 0. So the minimum possible value of 20 plus 2A, which is equal to 20, will be the correct answer. In this question, we are told that the mth and the nth term of a geometric progression are 3 by 4 and 12 respectively, where m is less than n. We are also told that the common ratio of the geometric progression is r, which is an integer, and we are required to calculate the minimum possible value of r plus n minus m. So we are told that the mth term is 3 by 4. So let us assume that the first term of the geometric progression is a, and the common ratio is given to be equal to r. So a into r to the power m minus 1 is equal to 3 by 4. This is the mth term, and a into r to the power n minus 1 is equal to 12. This is also given to us. So if you look at what is given to us, and if you are comparing the second equation and the first equation, we can separate r to the power n minus 1 as r to the power m minus 1 into r to the power n minus m. So the second equation, that is a into r to the power n minus 1, is equal to a into r to the power m minus 1 into r to the power n minus m. We know that r to the power m minus 1 into a is equal to 3 by 4. So this would imply that 3 by 4 into r to the power n minus m is equal to 12, or the value of r to the power n minus m is equal to 16. Just for ease, let us assume that n minus m is equal to p, which will be another natural number because n is greater than m. So r to the power p is equal to 16, and we are asked to find out the smallest possible value of r plus p. What do we know about r and p? We know that r is an integer. So r can be either greater than or less than 0, and we are told that p is a natural number. P is a natural number because m is less than n. So if you are trying to identify what are all the possible values for the given equation, r to the power p is equal to 16, it will be either minus 4 whole square, or minus 2 to the power 4, or 2 to the power 4, or 4 to the power 2, or finally 16 to the power 1. We can express 16 as a integer to the power of a natural number in these different ways. And in each of the case, if you are calculating the value of r plus p, in the first one it is minus 4 plus 2, which is equal to minus 2. In the second case it is minus 2 plus 4, which is equal to 2. In the third case it is 2 plus 4, which is equal to 6, and 4 plus 2 is also equal to 6. And finally 16 to the power 1, the sum will be equal to 17. Of this, the minimum possible value is minus 2. So the smallest possible value of r plus n minus m is equal to minus 2 when r is equal to minus 4 and n minus m is equal to 2. So the correct answer is minus 2. In this question, it is given that a1, a2, etc. are all integers such that a1 minus a2 plus a3 minus a4 dot 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 plus or minus an is equal to n for all n greater than or equal to 1. We are required to find out the sum of a1 plus a2 plus dot 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 till a1023. So if you do the simple calculation, a1 will be equal to 1, a1 minus a2 is equal to 2. A1 minus a2 plus a3 is equal to 3, and so on. So if you look at it from these two equations, if you subtract 1 and 2, if you subtract the second equation from the first equation, you will get that a2 is equal to minus 1. Similarly, from the third equation and the second equation, if you subtract the second equation from the third equation, you will get that a3 is equal to 1. You can continue doing this forward. So for example, a1 minus a2 plus a3 minus a4 is equal to 4. This is the fourth equation. So if you subtract the fourth equation from the third equation, you will get that a4 is equal to minus 1. So you can see a very clear pattern. The pattern is that all the odd numbers, that is a1, a3, a5 and so on, are equal to 1, while all the even numbers, that is a2, a4, a6 and so on, are equal to minus 1. Now you are required to find out the sum of a51 plus a52 plus dot 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 plus a1021 plus a1022 plus a1023. This is equal to how much? Now a51 plus a52 will cancel each other because one of them will be 1 and the other one will be minus 1. Similarly, all the pairs of consecutive odd and even numbers will cancel each other. Similarly, a1021 plus a1022 will be equal to 0. So the final sum will equal that of a1023. And because 1023 is odd, it will equal 1. So the answer in this case is 1. In this question, we are given an equation in which we have 2 to the power 3x and 2 to the power 6x, and we are required to find out the real root of this equation. So if you look at the terms of the equation, one you have 2 to the power 6x and then you have 2 to the power 3x plus 2. You should immediately realize that if I substitute something for a variable for 2 to the power 3x, I'll get some sort of a cubic equation or a quadratic equation, and then I'll solve for it and then find out the value of 2 to the power 3x, and then I can find out the value of x. For example, in this case, if you assume that 2 to the power 3x is equal to a, 2 to the power 6x will be 2 to the power 3x whole square, which is equal to a square. Similarly, 2 to the power 3x plus 2 can be simplified as 2 to the power 3x into 2 to the power 2. So this will be a into 2 square is 4. So the given equation, which is 2 to the power 6x, is a square plus 2 to the power 3x plus 2 is 4a minus 21 is equal to 0. Now a square plus 4a minus 21 can be simplified as a plus 7 into a minus 3. This will equal 0. So a will equal either minus 7 or 3. Clearly, as a is 2 to the power 3x, it has to be greater than 0. So a cannot equal minus 7. Therefore, the value of a will be equal to 3. Now we will substitute what a actually represents. That is 2 to the power 3x is equal to 3. We will take logarithm on both sides. So this will be 3x is equal to log of 3 to the base 2, or x is equal to log of 3 to the base 2 divided by 3. If you look at the options, it is option B. In this question, we are given a sequence on the left hand side. It is 2n plus 1 plus 2n plus 3 plus dot 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 plus 2n plus 47. We are told that this is equal to 5280, and we are required to find out the value of 1 plus 2 plus 3 plus dot 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 till n. So as you can imagine, the first thing we have to do is find out the value of n. Once we find out the value of n, calculating the value of 1 plus 2 plus 3 till n is very straightforward. So if you look at the equation on the left hand side, let us first try to figure out the number of terms. The number of each of this is part of an arithmetic progression. The common difference is 2. So the initial term is 1 and the final term is 47. So it is 1, 3, 5, dot dot dot. We are only looking at the second term of each of the brackets. So the number of terms which are there is 47 minus 1 by 2 plus 1. So this will be 23 plus 1, which is equal to 24. So on the left hand side, there are 24 terms, each of them separated by 2. There are many ways in which you can calculate the sum. What I prefer to do is, I will simplify this as 2n into 24, which is the first term of each of the brackets, and there are 24 brackets, plus 1 plus 3 plus dot 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 till 47. we are told that this is equal to 5280. Now the second, the term in this bracket, that is 1 plus 3 plus dot 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 till 47, can be easily found out. There is a simple trick that you can remember, it is quite useful, which is that for consecutive odd integers starting from 1, their sum will always be a perfect square. So for example, 1 is equal to 1 square, 1 plus 3 is equal to 2 square, 1 plus 3 plus 5 is equal to 3 square, 1 plus 3 plus 5 plus 7 is equal to 4 square, and so on. That is the number of odd integers that are there on the left hand side. The sum of them will be the square of the number of terms. In this case, there are 24 odd numbers starting from 1. So this will equal 2n into 24 plus 24 square is equal to 5280. Knowing this shortcut is not the only way to solve it. You can solve it by doing the sum of the arithmetic progression, where the first term is 1 and the common difference is 2 and the number of terms is 24. You find it anyway, you are going to get the same answer, which is 24 square. So in this case, you can simplify this, that 2n into 24 plus 24 square is 576 is equal to 5280, or 48n is equal to 4704, or n is equal to 98. Now what you are required to find out is 1 plus 2 plus 3 dot 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 till n. So the sum will equal n into n plus 1 by 2. This is the sum of the first n natural numbers, which is n into n plus 1 by 2. Here the value of n is 98. So you can just substitute 98 in this. So it will be 98 into 98 plus 1, that is 99 by 2. You can simplify 98 by 2 as 49. So the required answer is 99 into 49. You can calculate this, it will be equal to 4851. You can either use the calculator or you can just do 99 into 49 is 4900 minus 49. That is because 4900 is 49 into 100 minus 49. So that will also be equal to 4851. Again, there are many ways in which you can do the calculations. With practice, you will be able to figure out what is the fastest way to solve this kind of questions. The answer in this case is 4851. In this question, we are given two sequences. One is 15, 19, 23, that is there is a common difference of 4. And the second one is 14, 19, 24, which is another arithmetic progression where there is a common difference of 5. And we are required to find out the common terms in these two sequences. So whenever you get this kind of a question, the first thing you should do is find out the first common term. And once you find out the first common term, you have to find out the LCM of the common differences. Once you get the LCM, then finding out the number of common terms is very easy. For example, in this case, we know that 19 is the first common term. So the first common term is 19. The second one is you have to find out the LCM of both the common differences. In this case, the LCM of 4 and 5 is equal to 20. So the common terms of both these sequences will be 19 plus 20d. So there will be something like 19, 39, 59 and so on. So all the terms where you add 20 to 19 or a multiple of 20 to 19 will be common between both these sequences. Now we are required to find out how many such terms exist. So it will continue to go on till we get 415 or the number crosses 415. Now you can easily find out that all the terms of this common sequence will be something like 20 into n minus 1, where n will start with 1, in which case the number will be 19. When n is equal to 2, the number will be 20 into 2, that is 40 minus 1, so that will be 39. When n is equal to 3, the number will be 20 into 60 minus 1, that is 59, and so on. This will continue to happen till n is equal to 20, in which case the number will be 20 into 20, that is 400 minus 1, so that will be 399. The next term in this sequence, when you add 20 to it, will be 419. But 419 is greater than 415. So 419 or any term greater than 415 will not be part of the first sequence. So the only common terms between the two sequences are 1, 19, 59 dot 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 till 399, which are n is equal to 1, n is equal to 2 dot 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 till 20. So the number of common terms is 20. Remember that whenever you are required to find out the common terms, first find out the first common term, in which case the first common term is 19. then find out the LCM of the two common differences, in which case the LCM is 20. So all the common terms will be of the form 19 plus 20d, and finding out the number of such common terms can be found out in multiple ways. In this case, we have found out that all the common differences, all the common terms are of the form 20n minus 1, where n starts with 1 and n ends with 20. So the number of such terms is 20. In this question, it is given that there are terms in an arithmetic progression a1, a2 dot dot dot, and we are required to find out the value of the sum of 1 by square root of a1 plus a2 plus 1 by square root of a2 plus a3 dot 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 for n terms. The final term will be 1 by square root of an plus square root of an plus 1. In the examination, this kind of a question can be easily answered by substituting the value of n to be equal to 1 and then 2 and then so on. For example, if you substitute the value of n to be 1, the sum will be the sum of the first one term, that is 1 by square root of a1 plus a2. If you see and substitute the value of n to be 1, option C will become 0, option B will become 0, and option A will become 1 by square root of a1 minus square root of a2, which is not correct. And the only option, the correct option will be option A, where when you substitute the value of n to be 1, this will become 1 by square root of a1 plus square root of a2. So immediately you can tick A and go to the next question. So this is a shortcut to do these kind of questions, but if you want to solve it and find the value, we can do it now. So let us assume that the sum is S, which is equal to 1 by square root of a1 plus square root of a2 plus dot 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 plus 1 by square root of an plus square root of an plus 1. Now for the first term, multiply the numerator and denominator by square root of a2 minus square root of a1, because then the denominator will become a2 minus a1, and because a2 minus a1, a2, all these terms are in arithmetic progression, a2 minus a1 will become equal to d, which is the common difference. So if you just substitute that here, this will become s is equal to square root of a2 minus square root of a1 by a2 minus a1 plus square root of a3 minus square root of a2 by a3 minus a2, and then so on, and the last term will become square root of an plus 1 minus square root of an by a of n plus 1 minus a of n. Now if you observe closely, all the denominators will equal the common difference d, because they are all in arithmetic progression. And then if you take the common denominator as d, the terms other than the first and the last will get cancelled. That is, here it is square root of a2, and in the second one it is minus of square root of a2. Similarly, the third term, for example, would have been square root of a4 minus square root of a3 by d. Again, a3 over here will get cancelled with a3 over here. And the only terms that will remain are the last term, which has a positive value, which is square root of an plus 1 minus, and the first term which has a negative value, which is square root of a1. The key to simplifying this is that the denominators for each of these terms are the same, because they are in arithmetic progression. So once you have this as square root of an plus 1 minus square root of n by d, you can again simplify this by multiplying the numerator and the denominator by square root of an plus 1 plus square root of a1. Then the numerator will become, this will equal an plus 1 minus a1 by d into square root of an plus 1 plus square root of a1. Now again, as these are in arithmetic progression, an plus 1 minus a1 will equal n into d. This is equal n into d by d into square root of an plus 1 plus square root of a1. You can cancel d, which is the common difference, and the final answer will be n by square root of an plus 1 plus square root of a1. So again, as you can see, the correct answer is option A. This is the answer.
Google search Krakow free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis, and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question, we are given two equations. 5.55 to the power of x is equal to 0.555 to the power y is equal to 1000. Now, once this is given, we are required to find out the value of 1 by x minus 1 by y. So, the two equations we are given are similar to each other. 5.55 to the power x is equal to 1000 and 0.555 to the power of y is equal to 1000. We'll take logarithm on both the sides. Therefore, x is equal to logarithm of 1000 to the base 5.55 and y is equal to log of 1000 to the base 0.555. We are required to find out 1 by x minus 1 by y. So, we will find out that 1 by x is equal to log of 5.55 to the base 1000 and 1 by y is equal to log of 0.555 to the base 1000. For beginners, there is a very simple theorem on logarithms, which is that if x is equal to log of a to the base b, then 1 by x is equal to log of b to the base a. We have just used this formula twice in both the equations. Now we will subtract 1 by x minus 1 by y is equal to log of 5.55 to the base 1000 minus log of 0.555 to the base 1000. This will equal log of 5.55 by 0.555 to the base 1000. This is another simple formula, which is that if x is equal to log of a to the base c minus log of b to the base c, then x will equal log of, notice that the base in both the cases is the same, then this will equal a by b to the base c, which is what we have used here. The corollary is that if x is equal to log of a to the base c plus log of b to the base c, then x will equal log of a into b to the base c. Notice again that the base has to be same in both the cases. Anyway, using the earlier formula, we will get 1 by x minus 1 by y is equal to log of 5.55 by 0.555 to the base 1000. This will equal log of 10 to the base 1000. Now we can easily find out that 1000 is equal to 10 cube. Therefore, the value of this logarithm will equal 1 by 3. Therefore, the answer that we are looking for is 1 by 3. 1 by x minus 1 by y, when simplified, you are going to get a value of 1 by 3. In this question, it is given that if the population of a town is p at the beginning of the year, at the beginning of the next year, it becomes 2p plus 3. Now, we are told that at the beginning of 2019, the population of the town is 1000. We are required to find out the population at the beginning of 2034. So, if at the beginning of the first year, the population is p, at the beginning of the second year, it becomes 2p plus 3. And at the beginning of the third year, this term is multiplied by 2 and 3 is added to it. So, when this is multiplied by 2, we are going to get 4p plus 3 into 2 from here, and an additional 3 is added. So, this becomes 4p plus 3 into 1 plus 2. Now, at the beginning of the fourth year, this term is again multiplied by 2 and then 3 is added. So, this becomes, first 4p when multiplied by 2 is 8p, and 3 into 1 plus 2 into 2 becomes 3 into 2 plus 4, and then an additional 3 is added. So, this becomes 8p into 8p plus 3 into 1 plus 2 plus 4. Similarly, at the beginning of the fifth year, it becomes, this entire term is multiplied by 2. So, it becomes 16p plus 3 into 2 plus 4 plus 8, and an additional 3 is added plus 3. So, this becomes 16p plus 3 into 1 plus 2 plus 4 plus 8. Now you can see a pattern emerging. So at the beginning of the nth year, the total number becomes 2 to the power n minus 1 into p plus 3 into 1 plus 2 plus dot dot dot. Here there will be n minus 1 terms. So this becomes plus 2 to the power n minus 2. Now if you are looking at the question that is given, 2019, that is at the beginning of the first year, there is 1000, and 2034, here notice that 2019 is the first year, 2020 will be the second year, and 2034 will be the 16th year. Notice that it will be the 16th year and not the 15th year, because these kind of things matter in this calculation. So at the beginning of the 16th year, the total will be 2 to the power 15 into p plus 3 into 1 plus 2 plus dot 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 plus 2 to the power 14. We'll substitute 1000 in place of p once the calculation becomes more straightforward. So this is 2 to the power 15 into p plus 3 into 1 plus 2 plus dot 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 plus 2 to the power 14 is actually equal to 2 to the power 15 minus 1. So this will be 2 to the power 15 into p plus 3 minus 3. Here if you substitute 1000 in place of p, the answer that you are going to get is 1003 into 2 to the power 15 minus 3. This is the answer. This is a slightly calculation intensive problem, and you have to ensure that you don't commit any silly mistakes when you are making the calculation. In this question it is given that there is a club which has 256 members, of which 144 can play football, 123 can play tennis, and 132 can play cricket. Immediately after reading the first sentence, you should know that this is a Venn diagram question, because there are different members who can play either cricket or football or tennis or more than one of the two. So let us first draw the three diagrams. This is a football, this is tennis, and this is a cricket. This is football, this is tennis, and this is cricket. The total number of people in the club is 256. Football is played by 144, tennis is played by 123, and cricket is played by 132. 58 people can play both football and tennis, that is these two. 25 can play cricket and tennis, that is these two. And 63 can play both football and cricket, that is these two. So as we are given the intersection of two elements, let us first assume that the total number of people who can play all the three games is P. So the number of people who can play exactly football and tennis, only those two, will be 58 minus P. As 58 people can play both football and tennis, and P people can play all three games, the number of members who can play only football and tennis is 58 minus P. Similarly, as 25 people can play both cricket and tennis, and P people play all three games, the number of people who can play only tennis and cricket is 25 minus P. Similarly, 63 play football and cricket, so the number of people who play only these two will be 63 minus P. Now once you have it, we can fill all the three numbers which represent the number of people who play only football, who play only tennis, and who play only cricket. Because the total number of people who play football is 144, we'll have to calculate the sum of these three numbers, that is 58 minus P plus P is 58. 58 plus 63 minus P is 58 plus 63 minus P. This will be 121 minus P. So the number of people who play only football is 144 minus 121 minus P. This will be 23 plus P. So the number of people who play only football is 23 plus P. This is because if you sum this, and this, that is the four numbers of people who play football, the total has to come to 144. Similarly, to find out the number of people who play only tennis, let us calculate the sum of 58 minus P plus P, this is 58, and 58 plus 25 minus P, this will equal 83 minus P. So the number of people who play only tennis will be 123 minus 83 minus P. This will be P plus 40. We'll do the same calculation to find out the number of people who play only cricket. So 63 minus P plus P is 63. 63 plus 25 minus P is 88 minus P. So we'll subtract 88 minus P from 132, which is the total number of people who play cricket. This will come to 44 plus P. Now we have each of the individual cells together, and we know that the total number of people who are members of the club is 256. So if we sum all these individual elements, we should get 256. Using that, we can solve for P. So that will imply that 23 plus P plus 58 minus P plus P plus 63 minus P plus 40 plus P plus 25 minus P plus 44 plus P should equal 256. If you calculate the sum of all of them, you are going to get that this is 253 plus P is equal to 256. Using this equation, you can solve that P is equal to 3. And the question that we are asked is the number of members who play only tennis. The number of members who play only tennis is 40 plus P. 40 plus P in this case, as we know that P is equal to 3, will be 43. So the answer that you are looking for is 43. In this question, we are told that there is a series a to the base n such that a1 plus a2 plus dot 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 plus an is equal to 3 into 2 to the power n plus 1 minus 2 for every n greater than or equal to 1. We are required to find out the value of a11. So it is quite easy. Let us first write down that a1 plus a2 plus dot 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 plus a to the power 11 is equal to 3 into 2 to the power 11 plus 1, that is 12 minus 2. Over here we have just substituted n is equal to 11. Now when you substitute n is equal to 10, you are going to find a1 plus a2 plus dot 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 plus a10 is equal to 3 into 2 to the power 11 minus 2. Now what we do is, this is the first equation and this is the second equation. We'll just subtract the second equation from the first equation, because we can cancel all the common terms. Then you will get the only term that will remain on the left hand side is a11. a11 is equal to 3 into 2 to the power 12 minus 3 into 2 to the power 11, which is equal to 3 into 2 to the power 12 minus 2 to the power 11. This will actually equal 3 into 2 to the power 11. Note that 2 to the power 12 minus 2 to the power 11 is 2 to the power 11. So 2 to the power 11 is 2048. So 3 into this will be 6144. So the answer that you are looking for is 6144. In this question, it is given that m and n are integers and we need to find out the value of m such that the given equation is satisfied. There is an equation where you can see there are powers of 2 and 3 on the left hand side as well as the right hand side. So in these kind of questions, let us first segregate all the powers of 2 and all the powers of 3 on one side, so that then we can equate each one of them. Because m and n are real numbers, m and n are integers, the power of 2 on the left hand side should equal the power of 2 on the right hand side. Similarly, the power of 3 on the left hand side should equal the power of 3 on the right hand side. Then we will get two equations in m and n. We can solve them to get the answer. So let us simplify the left hand side first. The left hand side is square root of 2 to the power 19, that is 2 to the power 9.5 into 3 to the power 4, which is fine, into 4 square is 2 to the power 4 into 9 to the power m is 3 to the power 2m into 8 to the power n is 2 to the power 3n. This is the left hand side. We can simplify this by getting all the powers of 2 on one side and 3 on the other side. So this will be 2 to the power 9.5 plus 4 plus 3n into 3 to the power 4 plus 2m. This is the left hand side. Now let us look at the right hand side. Right hand side will be 3 to the power n into 16 to the power m will be 2 to the power 4m into 1 by 4 to the power 64. 64 is 2 to the power 6. 2 to the power 6. So this will be 2 to the power 6 by 4. So if you simplify this, this will be 2 to the power 4m plus 6 by 4 is 1.5 into 3 to the power n. So now for left hand side to be equal to right hand side, the power of 2 on both sides should be the same and the power of 3 on both sides should be the same. This is because m and n are integers. So if we equate both of them, it will be that 9.5, this is we are equating the power of 2 plus 4 is 13.5 plus 3n is equal to power of 2 on the right hand side, that is 4m plus 1.5. And equating the power of 3, 4 plus 2m is equal to n. We can simplify this and we will get 3n plus 12 is equal to 4m. And we have 4 plus 2m is equal to n. We need to find out the value of m in the question. So we will substitute the value of n from the second equation in the first equation. So n is equal to 4 plus 2m plus 12 is equal to 4m. You can simplify this, you will get 12 plus 6m plus 12 is equal to 4m, or minus 2m is equal to 24, or m is equal to minus 12. So the answer in this case is minus 12. We have just simplified the powers of 2 and 3 on both the sides and equated them to get the answer. In this question we are given two equations. We are told that x and y are positive real numbers. We are given two equations in logarithms of x and y, and we are required to find out the value of the product x into y. So if you look at the first equation, it is quite easy to simplify this. This is log 5 x plus y plus log of x minus y to the base 5. So if you are combining both of them, you are going to get, this will be x plus y into x minus y is equal to 3. We know that there is a simple formula for logarithms. This is log a to the base c plus log of b to the base c is equal to log of a into b to the base c. We'll use the same function, same formula here. So this will imply that log of x square minus y square to the base 5 is equal to 3, or you can remove logarithms, and so it will be x square minus y square is equal to 5 cube, which is equal to 125. This is the first equation that you have. If you look at the second equation, log of y to the base 2 minus log of x to the base 2 is equal to 1 minus log of 3 to the base 2. If you look at the LHS, it is the left hand side, it is to the base 2. So we'll convert the right hand side also to the base 2. First again we'll use the formula that we discussed now. So this will be log of y by x to the base 2 is equal to, we can represent 1 as log 2 to the base 2 minus log of 3 to the base 2. So this will be log of 2 by 3 to the base 2. Then we can cancel off log to the base 2. So this will be y by x is equal to 2 by 3, or x is equal to 3y by 2. This is the second equation. Now we can substitute the value of x that we found out in terms of y in the first equation to get the value of y. So as x is equal to y by 2, x square is equal to 9 by 4 y square. Therefore x square minus y square will be 9 by 4 y square minus y square is equal to 125. If you simplify, you are going to get y square is equal to 100, or y is equal to 10. Note that we know that y is a positive number, so y can't be minus 10. So x is equal to 3y by 2, which is equal to 15. So the required product, that is x into y, is equal to 10 into 15, which is equal to 150. So the required answer is 150. To solve this, we just use the basic formulas of logarithms, which is that 1 can be represented as log 2 to the base 2, and the sum of two logarithms of the common base will be the product. In this question, we are required to find out the number of paths from the point 1, 1 to the point 8, 10 via the point 4, 6. Now, each step that you take is either to the right or to the top. So, it should be either parallel to the x-axis or parallel to the y-axis. So, let us assume that these are the two axes. Now, suppose that this is the initial point. This is 1, 1. Let us name this point as A. And this is the final point 8, 10. Let us name this as B. And then there is a point in the middle which is 4, 6. Let us assume that this is point C. So, we need to go from A to B, but we have to first go to C. So, to find out the total number of ways in which this is possible, let us first calculate the number of ways in which you can go from A to C. Let us assume that this is, say, X number of ways. We will also find out the number of ways in which you can go from C to B. Let us assume that this is Y. Then the required answer is X into Y. Now, to go from A to C, you have to go 3 steps to the right and 5 steps to the top. This is because this is 4 minus 1, that is 3 steps to the right, and 6 minus 1, that is 5 steps to the top. Now, the order in which you choose the 3 steps to the right doesn't matter. That is, you can either go all the 3 steps at the start and then traverse 5 steps, or you can first go 1 step to the right, go 3 steps to the top, and again go 1 step to the right and go the remaining 2 steps to the top, and then finally take the last remaining step to the right. The order in which you choose these 8 steps doesn't matter, but amongst the 8, that is 3 plus 5 steps, there should be 3 steps to the right. So the number of ways in which you can choose 3 steps to the right amongst the 8 steps that you take in total is 8C3. So to go from A to C, you have to take a total of 8 steps, and amongst these 8 steps, there should be definitely 3 steps which are to the right. Once you select the 3 steps to the right, the remaining 5 steps will be to the top, so you need not choose them. So the number of ways in which you can do that is 8C3. This is the value of X that we discussed earlier. 8C3 will be 8 into 7 into 6 by 6, which is equal to 56. Similarly, to go from C to B, you have to go 4 steps to the right and 4 steps to the top. This is because 8 minus 4 is 4 and 10 minus 6 is 4. So you have to take a total of 8 steps, that is 4 plus 4. But again, the order in which you go doesn't matter. At the end of the day, if you take 4 steps to the right and 4 steps to the top, you will end up at B. So the number of ways in which you can select which 4 steps you take out of these 8 steps is 8C4. This is equal to Y. So 8C4 will be 8 into 7 into 6 into 5 by 24. So if you simplify, this is going to be 70. 7 into 5 is 35, into 2 is 70. So the answer that you are looking for is X into Y, that is 56 into 70. You can use your calculator to find out that 56 into 70 will be 3920. So the answer that you are looking for is 3920. In this question, we are given an equation in X and we are required to find out the exact value of X. We are given 4 options and we have to figure out the value. So it is given that 2 to the power X is equal to 3 to the power log 2 to the base 5. In this question, we will use one important theorem in logarithms, which is that a to the power log b to the base c is equal to b to the power log a to the base c. So we can interchange a and b in this kind of an equation. This is a theorem in logarithm which will work if a, b and c are positive numbers wherein logarithms are defined. So in this case, what we will do is we will apply this theorem on the RHS. That is 3 to the power log 2 to the base 5 is equal to, we will interchange 3 and 2. So it will be 2 to the power log 3 to the base 5. Now remember that the base of the logarithm will remain the same. In this case, the base of the logarithm is c. Even in this case, the base of the logarithm is c. The only thing that will change is the exponent and the logarithm will be interchanged. That is, a and b will be interchanged. So even here, 3 and 2 will be interchanged, 5 will remain constant. So 3 to the power log 2 to the base 5 is equal to 2 to the power log 3 to the base 5. Now this is equal to 2 to the power x. Now, so we can infer that the value of x is equal to log of 3 to the base 5. Now let us look at the options. log 8 to the base 5 is definitely not the case. Log 9 to the base 5 is also not the option. Now the only two options that are there are 1 plus log 5 by 3 to the base 3 and 1 plus log 3 by 5 to the base 5. So we'll try to modify this into one of the options. So if you look at option D, it looks like this can be modified. So what we'll do is we'll write 3 as equal to 5 into 3 by 5. So log of 3 to the base 5 will be 5 into 3 by 5, which will actually simplify to 3 to the base 5. This is equal to log of 5 to the base 5 plus log of 3 by 5 to the base 5. Log 5 to the base 5 is 1 plus log of 3 by 5 to the base 5. So if you look at it, this is equal to option D. So the answer in this case is option D. The only formula that you need to remember to solve this kind of question is the one that we described at the start. That is a to the power log b to the base c is equal to b to the power log a to the base c. In this question, we are given that log 81 to the base 12 is equal to p, and we are required to find out the value of 3 into 4 minus p by 4 plus p. So when you are required to find out the value of 3 into 4 minus p by 4 plus p, and you notice that the value of p has log 81 to the base 12, one of the first things that you should think about is that let us divide the numerator and denominator by 4. So this becomes 3 into 1 minus p by 4 by 1 plus p by 4. Why is this important? Because this makes things very easy. That is because log 81 is equal to 3 to the power 4. So log of 81 to the base 12, which is equal to p, is 4 into log of 3 to the base 12. This is equal to p. Therefore, the value of p by 4 is equal to log of 3 to the base 12. Now, once you have everything in terms of p by 4, it becomes much more easier to simplify this. So 1 minus p by 4 is 1 minus log of 3 to the base 12. Here you can write 1 as log 12 to the base 12. So this will be log of 12 to the base 12 minus log of 3 to the base 12. Remember that log of a minus log of b is equal to log of a by b. So in this case, log of 12 to the base 12 minus log of 3 to the base 12 is equal to log of 4 to the base 12. Similarly, 1 plus p by 4 is equal to 1 plus log of 3 to the base 12. Again, we will write 1 as log 12 to the base 12 plus log of 3 to the base 12. Again, remember that log of a plus log of b is equal to log of a into b. So this becomes log of 36 to the base 12. Now we are required to find out 1 by p minus 4 by 1 plus p 1 by p plus 4. So the required ratio will be log of 4 to the base 12 by log of 36 to the base 12. This is equal to 1 minus p by 4 by 1 plus p by 4. Now this is simplified as log of 4 to the base 36. Why is this log of 4 to the base 36? Because log of a to the base c by log of b to the base c is equal to log of a to the base b. We'll use the same formula over here. So we can basically cancel 12 and make the denominator 36 as the base. Now 4 is 2 square and 36 is 6 square. So this becomes log of 2 to the base 6. We can basically cancel off both the squares, because you can simplify this as 2 log of 2 to the base 36, which is equal to 2 by 2 into log of 2 to the base 6. Again 2 and 2 get cancelled and this will become log 2 to the base 6. Now this is the value of 1 minus p by 4 by 1 plus p by 4. We need to calculate 3 times this number. So that will equal 3 into log of 2 to the base 6, which is equal to log of 2 cube. Whenever you are taking 3 inside, you have to make it to the power of. That will be 2 to the power of 3, which is equal to 8 to the base 6. So the required answer in this case is log of 8 to the base 6. All these calculations become very easy once you notice that p by 4 is equal to log 3 to the base 12, and we can simplify 4 minus p by 4 plus p as 1 minus p by 4 by 1 plus p by 4. Once you are done with both these steps, everything else is very easy. In this question it is given that we have to find out the number of numbers which have 2 or more digits which can be formed using the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, such that in each such number the digits are not repeated and all the digits appear in ascending order. So let us first find out how many numbers can be formed using 2 digits, then we will find out how many numbers can be formed using exactly 3 digits, and so on till 9 digits, because we have to find out all the numbers which have 2 or more digits. So suppose we are looking to find out numbers which have exactly 2 digits. Now we can select those 2 digits in 9C 2 ways. Now once we have selected the digits, because the digits have to appear in ascending order, we can't arrange them in any other manner. We have to arrange them in only one manner, which is the ascending manner. So for example, if we have selected the 2 numbers as 3 and 4, the selection is in our hands, but once we have selected them, the arrangement is not in our hands. They have to be arranged only in ascending order, which is 3, 4. Similarly, the number of ways in which we can select 3 digits out of these 9 digits will be 9C3. Now once we have selected the 3 digits, for example, let the 3 digits be 8, 5 and 2. Once we have selected 8, 5 and 2, we can arrange them in only one manner, and that one manner is the ascending manner. In this case it will be 2, 5 and 8. So over here, for each number, that is 2, 3, 4, 5, 6 dot 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 till 9, the only thing that is in our hands is selection. Once we have selected, arrangement is not in our hands. Therefore the number of 2-digit numbers that can be formed is 9C2. The number of 3-digit numbers that can be formed is 9C3. The number of 4-digit numbers that can be formed is 9C4, and so on. Similarly, the number of 9-digit numbers such that all the numbers are in ascending order that can be formed is 9C9. Therefore, the total number of numbers that can be formed using these 9 digits which have digits in ascending order, and the total number of digits is 2 or more, that is all the conditions are matching, will be 9C2 plus 9C3 plus 9C4 plus dot 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 till 9C9. Now we have to calculate this, and there is an easy way in which we can calculate it. For any number n, nc0 plus nc1 plus nc2 plus dot 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 plus ncn is equal to 2 to the power n. We can use a simple number like, say, to verify this. Suppose n is equal to 3. Therefore 3c0 plus 3c1 plus 3c2 plus 3c3 will equal 2 to the power 3, which is equal to 8. You can easily verify it because 3c0 is 1, 3c1 is 3, 3c2 is 3 and 3c3 is 1. So this number 1 plus 3 plus 3 plus 1 is equal to 2 cube, which is equal to 8. This is true for all values of n. So in this case we know that 9c0 plus 9c1 plus 9c2 plus dot 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 plus 9c9 is equal to 2 to the power 9. Now 2 to the power 9 is equal to 512. So the sum of 9c2 plus 9c3, that is the last part of the given sum, can be easily calculated because 9c0 is equal to 1 and 9c1 is equal to 9. So this required sum, that is 9c2 plus 9c3 plus dot 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 till 9c9, is equal to 512 minus 1 minus 9, which is equal to 502. You can individually calculate the value of 9c2, 9c3 dot 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 till 9c9 and the sum will equal 502, but this is an easier way in which you can calculate it. So the required answer in this case is 502. In this question it is mentioned that a class has 74 students and each of the student studies at least one of the 3 subjects H, E and P. So whenever you see phrasing of this sort, which is that a student likes at least one of 3 parameters, you know that this is a Venn diagram question. Wherever there is an overlap between 2 or 3 parameters, it is a Venn diagram question. So let us first draw the three circles. This is for H, this is for E, and this is for P. There are a total of 74 students in the classroom. Now 10 students study all the three subjects. So this is the area which is intersected by all the three circles. So it denotes the common number of students who like all the three subjects. Now 20 students study H and E but not P. So 20 students study H and E but they are not intersected by P. Now every student who studies P also studies H or E or both. What this basically means is that there is no student who studies only P, because anybody who is studying P always has an intersection with either H or E or both. So this would imply that the number of students who study only P is 0. If the number of students studying H, that is the total number of students studying H, equals the number of students studying E, that is H is equal to E, the number of students studying H is. So there are four areas in the Venn diagram which are not filled up. Let us fill them up with alphabets. Let us assume that this is A, this is the number of people who study only H, and B is the number of people who study H and P but not E, C is the number of people who study only E, and D is the number of people who study E and P but not H. Now what do we know about this? We know a few things. We know that A plus B plus C plus D plus 20 plus 10 represents all the students. And how many students are there in the class? This is equal to 74. This would imply that A plus B plus C plus D is equal to 44. 20 plus 10 is equal to 30. The next information we have is that the number of students who are studying H is equal to the number of students who are studying E. And what is the number of students who are studying H? This would be A plus B, this is A plus B plus 20 plus 10. Similarly, the number of students who are studying E will be C plus D, this is C and this is D, plus 20 plus 10, because 20 and 10 are common to both H and E. Now we are told that these two are the same. This would imply that A plus B is equal to C plus D. Now, but we already know that A plus B plus C plus D is equal to 44. What does this imply? This would imply that A plus B is equal to C plus D is equal to 44 by 2, which is equal to 22. Now assume that A plus B is a number which is equal to P and C plus D is another number equal to Q. What we know is that P is equal to Q and P plus Q is equal to 44. This would imply that both P as well as Q equal 22. That would mean that A plus B is equal to 22 and C plus D is also equal to 22. Now what are we required to find out? We are required to find out the value of H. That is the number of students who are studying H. This would be A plus B plus 20 plus 10. A plus B is 22 plus 20 plus 10. This is the value of H and this equals 52. So the answer in this case is 52.
We at Kraku provide all the previous year CAT papers along with many other MBA examinations such as IIFT, XAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question it is given that there are a total of 200 students, of which 105 like pizza and 134 like burger. Then we are required to find out the number of students who like only burger can possibly be. So what we'll do is we'll first draw, this is a Venn diagrams question clearly, because it is implied that there are some people who like only pizza, there are some people who like only burger, and there will be some people who like both pizza and burger, and also there will be some people who like neither of the two. So any question which has this sort of a setting, which is that there are more than one attributes that a particular student can like, you know that this is a Venn diagrams question. So suppose this circle represents all the students who like pizza and this circle represents all the students who like burger. We are told that 134 students like burger and 105 students like pizza. Now what are we required to find out? We are required to find out some interval where the number of students who like only burger can be. So let us assume that that interval is x. So x over here denotes the students, the number of students who like only burger. Then the intersection of the number of students who like both burger and pizza will be 134 minus x, because you want the total number of students who like burger to be 134. So the intersection between pizza and burger will be 134 minus x. Now this would imply that the number of students who like only pizza, that is people who are inside this area, will equal 105, which is the total number of students who like pizza, minus 134 minus x, which is the intersection between pizza and burger. So this will be, if you simplify, x minus 29. So this is going to be x minus 29. Now, so we know for sure that x is greater than or equal to 29, because you don't want x minus 29 to be negative. There will not be minus 10 students who like only pizza. That number has to be greater than or equal to 0. So you know that x is greater than or equal to 29. There is one more information that you will have to take care of, which is that the total number of students is 200. So the number of students who like pizza and burger has to be less than or equal to 200. Because why will it not be exactly equal to 200? Because you know that there can be some students who like neither pizza nor burger, and you know that that set of students is also greater than or equal to 0. So it would imply that the number of students who are within this union of pizza and burger has to be less than or equal to 200. If you calculate it, that will be x minus 29, that is this number of students who like only pizza, plus 134 minus x, which is the number of students who like both pizza and burger, plus x, which is the number of students who like only burger. This has to be less than or equal to 200. If you simplify x minus 29 plus 134 minus x, this will equal 105. So 105 plus x is less than or equal to 200, or x is less than or equal to 95. So you know that 95 is greater than or equal to x is greater than or equal to 29. This is the interval within which the number of students who like only burger falls in. Now let us look at the options. The first option is 23, but that is less than 29. So this is not the answer. Let us look at the second option. 26 is also less than 29. So this is also not the correct answer. The third option is 96, but you know that 96 is greater than 95. So this is also not the answer. The final option is 93, which lies within the interval that we have discussed before. So the correct answer is option D, which is 93. Remember that 93 is a possibility. We are not saying that the number of students who like only burger is definitely 93, but 93 falls within the prescribed range. So it is the correct answer. In this question, it is given that there are three positive real numbers called x, y, z, and they are in geometric progression. So x, y, and z are in GP. So let us assume that the common ratio of the geometric progression is r. So y is equal to x into r and z is equal to x into r square, such that x is less than y is less than z. So this would imply that because the geometric progression, the terms of the geometric progressions are increasing, the common ratio is greater than 1. The common ratio r is greater than 1. Now it is also given that 5x, 16y and 12z are in arithmetic progression. So 5x plus 12z is equal to 2 into 16y, because they are in arithmetic progression. Then the common ratio of the geometric progression is, remember that if there are three terms a, b and c who are in arithmetic progression, it would imply that they are of the form a, ar and ar square. This is if they are in GP. Similarly, if a, b and c are in AP, it would imply that a plus c is equal to 2 into b, that is 2b. We are just using that in this problem. Now we are required to find out the common ratio of the GP, that is we are required to find out the value of r. Now we will replace z with xr square and we will replace y with xr. So this given equation will become 5x plus 12 into xr square is equal to 2 into 16 xr, 2 times. Now this would imply that 5x plus 12x r square is equal to 32xr. We can cancel x from both sides because we know that x is positive, so it is not equal to 0. Now we will get a simple quadratic equation in r, so that will equal 12r square minus 32r plus 5 is equal to 0. Now you can easily factorize this, so this will become 12r square minus 30r minus 2r plus 5 is equal to 0, or 6r into 2r minus 5 minus 1 into 2r minus 5 is equal to 0, or this will be 6r minus 1 into 2r minus 5 is equal to 0. This would imply that r is equal to 1 by 6 or r is equal to 5 by 2. But remember that r is greater than 1. This geometric progression has terms which are increasing. So r cannot equal 1 by 6. So the value of r will equal 5 by 2. In this question, we are given two equations in x and y, that is two variables, and we are asked to find out what is the value of x square plus y cube. So if you look at the two equations, the first equation is that x to the power 2018 into y to the power 2017 is equal to half, and the second equation is that x to the power 2016 into y to the power 2019 is equal to 8. So if you look at both the equations, the powers of x and y, although individually they are huge, if you compare both the equations, they are kind of similar to each other. So what we'll do is quite simple. We'll divide the second equation by the first equation so that we can cancel out the powers of x and y as much as possible. So then you are going to get, if you compare this as the second equation and this as the first equation, you are going to get y square divided by x square is equal to 16, or y square is equal to 16x square, or y is equal to either 4x or minus 4x. So there are two possibilities here, that y is equal to 4x or y is equal to minus 4x. We will consider both the possibilities. So in the first case, we will assume that y is equal to 4x. In the second case, we will assume that y is equal to minus 4x. Then if you look at the first equation, we can use any one of the two equations. We can substitute the value of y in terms of x and calculate the value of x and then calculate the value of y. So if you are taking the first equation in this case, it will be x to the power 2018 into y to the power 2017. We will substitute 4x in place of y. So this will be 4 to the power 2017 into x to the power 2017 is equal to half, or x to the power 4035 into 2 to the power 4034. Note that 4 is equal to 2 square is equal to 2 to the power minus 1. If you take 2 to the power 4034 to the other side, it will be x to the power 4035 is equal to 2 to the power minus 4035. 4035 is an odd power, so you can simplify this as x is equal to 2 to the power minus 1 or 1 by 2. Therefore y will equal 4x, so that will equal 2. Now you are required to find out the value of x square plus y cube. So x square will be 1 by 4 and y cube will be 8. So the sum of these two will be 8 1 by 4, which is 33 by 4. So it is 33 by 4 in the situation where y is equal to 4x. Now let us substitute y is equal to minus 4x and again calculate what the answer will be. If y is equal to minus 4x, again we can substitute this in any one of the two equations. We will again substitute this in the first equation. So this will be x to the power 2018 into y to the power 2017 will be minus 4 to the power 2017 into x to the power 2017 is equal to 2 to the power minus 1, or x to the power 4035 into minus 2 to the power 204034 is equal to 2 to the power minus 1, or x to the power 4035 is equal to minus 2 whole to the power 4035. Minus 4035. So x will equal minus 1 by 2, or y will equal again minus 4x. So the value of y will again be equal to 2 because this is minus 4 into minus 1 by 2. So if you calculate the value of x square plus y cube, it will again equal 1 by 4 plus 8 or 33 by 4. So the required answer is 33 by 4, as that is the same in both the cases. In this question, we are given two equations in logarithms in a and b, In the first equation there is only log a, and in the second equation there is actually log b and there is a, and we are required to find out the value of a plus b. So what we'll do is very simple. We'll use the first equation to find out the value of a, and we'll substitute the value of a in the second equation and use the second equation to find out the value of b, and then find out the value of a plus b. So let us first simplify the first equation. It says that log of 5 plus log a to the base 3 whole to the base 2 is equal to 3. Now if you want to remove logarithm on the left hand side and take 2 to the right hand side, it will be 5 plus log of a to the base 3 is equal to 2 cube, which is equal to 8, or log of a to the base 3 will equal 8 minus 5, which is equal to 3, or a will equal 3 to the power 3, which is equal to 27. Now let us look at the second equation. The second equation says that log of 4a plus 12 plus log of b to the base 2 whole to the base 5 is equal to 3. Now let us simplify 4a plus 12. We have already calculated that a is equal to 27. So 4a is equal to 27 into 4, which is equal to 108. So 4a plus 12 will equal 108 plus 12, which is equal to 120. Now if you want to remove logarithm on the left hand side, it will be 4a plus 12 plus log of b to the base 2 is equal to 5 cube, which is equal to 125. But we have already calculated that 4a plus 12 equals 120. Therefore, log of b to the base 2 will equal 125 minus 120, which is equal to 5, or b will equal 2 to the power 5, which is equal to 32. Now we need to calculate the value of a plus b. The value of a is 27 and the value of b is 32. Therefore, a plus b will equal 27 plus 32, which is equal to 59. So the answer in this case is 59. In this question, it is given that we are required to find out how many 2-digit numbers with a non-zero digit in the units place are there, which are more than thrice the number found by interchanging the positions of its digits. So let us assume that the 2-digit number that we are discussing is AB. Now the value of this number will equal 10A plus 2B. It is quite simple. Suppose the 2-digit number is 29. Its value will equal 10 into 2 plus 9, which is equal to 29. That's what we are saying. In this, it is given that the units digit is non-zero. So B is not equal to 0. Because it is mentioned that it is a 2-digit number, even A will equal non-zero. Now, once we interchange the digits, the number we will obtain is BA, and its value will equal 10B plus A. Now we are told that the original number is more than thrice the number found by interchanging its digits. So AB, the actual number AB, is greater than 3 into BA. Now the value of AB is 10A plus B. This has to be greater than 3 into 10B plus A, or 10A plus B has to be greater than 30B plus 3A. You can bring A to this side and B to this side. So 7A is greater than 29B. We need to find out how many numbers AB exist such that 7A is greater than 29B. Let us assume that B is equal to 1. Remember that B can't be equal to 0. If B is equal to 1, the right hand side will equal 29. So A has to be, 7A has to be greater than 29, or A has to be greater than 4. So the values that A can take are 5, 6, 7, 8 and 9. Now if B is equal to 2, 29B will equal 58. So 7A has to be greater than 58, or A has to be greater than 8. Therefore the only value that A can take is that of 9. Now if B is equal to 3, 29B will equal 87, and 7A has to equal something like greater than 14, which is not possible because both A and B are single digit numbers. So when B is equal to 3 or higher, we will not have any values for A. So the total number of solutions for this is equal to 1, 2, 3, 4, 5. That is 5 values of A are possible when B is equal to 1, and 1 value of A is possible when B is equal to 2. So the total is 5 plus 1, which is equal to 6 possible values. The 6 possible 2-digit numbers in this case are 51, 61, 71, 81, 91. This is when the units digit b is equal to 1, and 92 when the units digit b is equal to 2. So the total number of possibilities is 6. In this question it is given that whenever there are two sets A and B, the operator triangle represents all the elements which belong to either set A or set B but not to both. Now we are given 4 sets P, Q, R and S, and we are required to find out the number of elements in the bigger set P triangle Q, whole triangle of R triangle S. So in this case we will first figure out what are the elements in P triangle Q, then we will figure out the elements in R triangle S, and then we will figure out which elements will be present in the whole bigger triangle set. Okay. Now when we are trying to figure out the elements in P triangle Q, let us first identify the common elements between P and Q. The common elements between P and Q are 2 and 3. So P triangle Q contains all the elements which are in either P or in Q but not equal to 2 and 3. So that will be 1, 4, 5 and 6. Similarly, if you are trying to find out R triangle S, let us first identify the common elements between R and S. The common elements between R and S, if you notice, will be that only 9 is the element which is common to both R and S. So R triangle S will contain all the other elements which are either in R or in S. In this case that will be 1, 2, 3, 4, 7, 8 and 10. Now if you are trying to put a bigger operator, the triangle between these two sets, that is P triangle Q and Q triangle S, we will again try to identify which are the elements which are common. You can see that 1 is common between both the sets and 4 is common between both the sets. There is no other common element. So the whole triangle, that is P triangle Q, whole triangle R triangle S will be, it will contain all the other elements. So in this case it will contain 2, 3, 5, 6, 7, 8 and 10. Now we are required to find out the number of elements of this set. The number of elements is 1, 2, 3, 4, 5, 6 and 7. So the number of elements of this bigger set is 7. In this question it is given that there is a tournament in which there are 43 junior level and 51 senior level participants. So there are 43 junior level participants and 51 senior level participants. Each pair of juniors play one match, each pair of seniors play one match. So basically the 43 juniors play matches amongst themselves, and the number of matches that they will play will be 43 C2. Basically you will have to select 2 juniors amongst 43. Similarly the number of matches that the seniors will play will be 51 C2. There is no junior versus senior match, so they don't play matches against each other. They only play amongst their own groups. The number of girl versus girl matches in junior level is 153, while the number of boy versus boy match in senior level is 276. The number of matches a boy plays against a girl is. So let us assume that in this junior level there are small g number of girls and small b number of boys. So g plus b is 43. Similarly in the senior level, let us assume that there is capital G girls and capital B boys. In this case capital G plus capital B is equal to 51. What is given in the question is that the number of girl versus girl matches in junior level is 153. That is small g C2 is 153, or g into g minus 1 by 2 is equal to 153, or g into g minus 1 is equal to 153 into 2, which is equal to 306. You can solve for this. You can easily get the answer of g as equal to 18. There are multiple ways in which you can solve this. One of the ways that I would assume to calculate the answer quite easily is that, notice that g into g minus 1 is increasing. That is, as the value of g increases, g into g minus 1 will increase, and this is close to 306, which is close to 17 square, that is 289. So I would look around for answers. I look around for numbers between around 17, and you can figure out that if you substitute g is equal to 18, you are going to get the answer. So this value of small g is equal to 18. Similarly, we are even given that the number of boy versus boy matches in senior level is 276. That is capital B C2 is equal to 276, or b into b minus 1 by 2 is equal to 276, or b into b minus 1 is equal to 276 into 2, this is equal to 552. Again, you can use multiple ways to calculate it. You can expand it as a quadratic equation to solve it, but again you will understand that the value for b that you are going to get is 24. How did I arrive at this? Because 552 is close to 576. Now if you do rough trial and error, you can figure out that when b is equal to 24, b into b minus 1 is 552, which is solved. So the value of capital B is 24, the value of small g is 18. Using this, we can calculate the value of small b. The value of small b will be 43, which is the total number of juniors, minus the number of girls, that is 18. So 43 minus 18 is 25. Similarly, the value of capital B is 24. Therefore, the value of small g will be, capital G will be 51, which is the total number of seniors, minus 24, which is the number of boys. So this will equal 27. Now when you are required to find out the number of matches a boy plays against a girl, we will find out the number of matches in junior level and the number of matches in senior level and then sum them up. As there are 25 boys and 18 girls, the number of matches between them will be 25 into 18. 25 into 18, if you calculate, will be 450. Similarly, the number of boy versus girl matches in senior level will be 24 into 27. You can again calculate this. This will be 108 into 6. This will be 648. So this is 648 in senior level and 450 in junior level. So the total number of boy versus girl matches will be 648 plus 450. This, if you sum it up, will be 1098. In this question, we know that a1, a2, a52 are 52 positive integers, such that a1 is less than a2, a2 is less than a3, and so on till a52. We are also told that their arithmetic mean is 1 less than the arithmetic mean of a2 to a52. It is given that a2 is 100, then the largest possible value of a1 is what? So let us first put down what our information has been given. It has been given that a1 plus a2 plus plus a52. The arithmetic mean of these 52 numbers will be by 52, and the arithmetic mean of the 51 numbers that are given later is a2 plus a3 plus plus a52. Now because there are 51 numbers, the arithmetic mean will be their sum by 51. Now if you are assuming that the later arithmetic mean is equal to a, it has been given that the arithmetic mean of all the 52 numbers is a minus 1. This is the information that is given to us. We are also told that a52 is equal to 100, but we will come to that later. Now what we are required to find out is the largest possible value of a1. So let us try to first find out the sum of a2 to a52. So a2 plus a3 plus plus a52 will be equal to 51 into a. We have assumed that the average of a2 to a52 is a. Now we will substitute this sum in the first equation. Then we can get something about a1, we will get an equation about a1 in terms of capital A, and then we will try to maximize it. So if you are substituting that the sum of a2 to a52 is equal to 51a in the first equation, it will become a1 plus 51a divided by 52 is equal to a minus 1, or a1 plus 51a is equal to 52a minus 52, or a1 is equal to a minus 52. So if you want to maximize a1, you have to maximize the average of the remaining 51 numbers, that is from a2 to a52. But it has been given that a to a52 is equal to 100, and we also know that a1 to a52 are in ascending order. So in order to maximize the average of a2 to a52, we have to assume that because a52 is equal to 100, a51 will be the largest possible number, which is just less than a52, which is equal to 99. Similarly, a50 will be 1 lesser, which will be 98. All these are positive integers which are less than one another. So if you continue to do that, you will find out that a2 will equal 50. And the average of these 51 numbers will be 50 plus 51 plus plus 99 plus 100 whole divided by 51. You can easily see that even by symmetry the average will equal 75. You can even calculate the sum of this series of natural numbers, or you can also find out that 50 and 100 the average is 75. Similarly, the average of 51 and 99 is 75. Similarly, you can always find two numbers on either sides of 75 which will be in the middle, whose average will be 75. So the average of these 52 numbers from 100 to 50 will equal 75. So the maximum possible value of A, which is the average of the 52 numbers A2 to A52, is equal to 75. Therefore, the maximum possible value of A1 will be 75 minus 52, which is equal to 23. So what we have done in this question is, first assume that the average of A2 to A52 is capital A, then found out the value of A1 in terms of capital A, and then we have tried to maximize capital A. We have figured out that the average of these 51 numbers has to be less than or equal to 75. Therefore, A1 has to be less than or equal to 23, and the largest possible value equals 23. In this question, we are given a sum 7 into 11 plus 11 into 15 plus 15 into 19 dot 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 till 95 into 99, and we are required to find the sum of it. So let us assume that the sum is equal to S. So we have to find out the value of S, where S equals 7 into 11 plus 11 into 15 plus 15 into 19 plus dot 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 plus 95 into 99. If you are looking at any of the terms, you can see that each of the numbers is differing by 4. That is, 7 is less than 11 by 4, 11 is less than 15 by 4, and 15 is less than 19 by 4, and so on. Now the first term is 7. So basically the nth term of this series will be 4n plus 3 into 4n plus 7. The first term, if you put n is equal to 1, will be 4n plus 3, that is 4 into 1 plus 3, that is 7. And the second term will be 4n plus 7. When you put n is equal to 1, it will be 11. Similarly, when you put n is equal to 2, 4n plus 3 will be 11, and 4n plus 7 will be 8 plus 7 is 15. So it will be 11 into 15. So the nth term of this series is S is equal to 4n plus 3 into 4n plus 7. We have to find the sum. The sum is called sigma. So where does n vary from? The first term is when n is equal to 1, and the last term is when 4n plus 3 is equal to 95, or n is equal to 95 minus 3 is 92 by 4, which is 23. So we have to find the sum of all the terms where each term is of the form 4n plus 3 into 4n plus 7, where n varies from 1 to 23. Now if we simplify this, it will be 16n square plus 3 into 4n is 12n plus 4n into 7 is 28n plus 21, or this will be 16n square plus 40n plus 21, where n varies from 1 to 23. Now we will split each of the three terms, that is, we will split the terms with n square, we will split the terms with n, and we will split the terms with 21. So this will be 16 into sigma n is equal to 1 to 23 of n square plus 40 into sigma n is equal to 1 to 23 n plus sigma n is equal to 1 to 23 21. What this basically means is we have to calculate the sum of the squares of all the natural numbers from 1 to 23 and multiply it with 16. Similarly, we have to calculate the sum of all the natural numbers from 1 to 23 and multiply it with 40. And for the last term, we are using 21 in each of the terms, and there are 23 such terms. So the last term will easily add up to 21 into 23, because in each term we are adding 21 and there are 23 such terms. To calculate sigma n from 1 to 23, we know the formula. The formula for sigma n is the sum of the natural numbers up to n. This is equal to n into n plus 1 by 2. This is a very easy formula and a very common formula. When you substitute n is equal to 23 in this, it will be 23 into 24 by 2, which is equal to 23 into 12. So the second term will be 40 times that will be 40 into 23 into 12. Now the first term is the sum of the squares of all natural numbers from 1 to 23 and 16 times that. Now we have a formula, well-known formula about sum of the squares. Similar to sum of natural numbers, the sum of the squares has a formula which is n into n plus 1 into 2n plus 1 by 6. So if you want to calculate the sum of all the squares of all the natural numbers from 1 to 10, you have to just substitute n is equal to 10 in this. Because we want to calculate the sum of the squares of all the natural numbers till 23, we will substitute n is equal to 23 in this formula. And it will become 23 into 24 into 23 into 2 plus 1 is 47 by 6. So this will be 92 into 47. So this will be 16 into 23 into 4 into 47. We have to calculate the sum of this. You can use your calculator to calculate it. One easy way in which you can calculate this even using calculator lesser number of times is first taking 23 common, because all the terms have 23 in them. So if you take 23 common, the first term will be 16 into 4, that is 64 into 47. Plus if you take 23 common here, it will be 40 into 12, that is 480. And the last term will be 21. 480 plus 21 is 501. And 64 into 47, you can use your calculator to find out. I would do it as 64 into 50, which is equal to 3200, minus 64 into 3 is 192, so that will be 3008. So this will be 23 into 3008 plus 501 is 3509. You can use a calculator and you can find out that this will total to 80,707, which is the answer. In this question, it is given that n and x are positive integers such that n to the power n is 2 to the power 160 and n square plus 2 to the power n is an integral multiple of 2 to the power x. Now we are required to find out the largest possible value of x. Now if you look at the first equation that is given, it is given that n to the power n is 2 to the power 160. Here there is only one variable, the variable is n, and you have one equation. So it should be possible to solve for the value of n. Now let us try to solve for n. Once we find out n, we will try to understand what n square plus 2 to the power n represents, and then try to figure out what is the value of x, the largest possible value of x. So if you are looking at n to the power n, if this equals 2 to the power 160, here the number is much less than the exponential. The number over here is 2 and the exponent is 160. So let us try to get both of them closer to each other. You can represent 2 square as 4. So this will be n to the power n is equal to 4 to the power 80. Even now the number is much less than the exponent. If we try to make it look like 2 to the power 4, which is equal to 160, 2 to the power 4 is equal to 16. So this will be equal to 16 to the power of 40, n to the power n. We are basically dividing the exponent by 4 and raising 2 to the power 4. So this will be 16 to the power 40. Even over here you can see that 16 is less than 40. If you try to check the next number, which is 2 to the power 5, which is equal to 32. So n to the power n is equal to 32 to the power 160 by 5, which is also equal to 32. So n to the power n is equal to 2 to the power 160, which can be represented as 2 to the power 5 and 2 to the power 160 by 5. This is equal to 32 to the power 32. Here you can understand that n has to equal 32. So by trial and error we can figure out that the value of n is 32. Now if you are looking at n square plus 2 to the power n, this will equal 32 square plus 2 to the power 32. Let us write 32 as 2 to the power 5. So 32 square will be 2 to the power 10. So this will equal 2 to the power 10 plus 2 to the power 32. Now we are told that this is an integral multiple of another number called 2 to the power x, where x is a positive integer. And we have to figure out the maximum possible value of x. So you can simplify 2 to the power 10 plus 2 to the power 32 as follows. You can take 2 to the power 10 common between both of them. So this becomes 1 plus 2 to the power 22. Now we are told that this is an integral multiple of 2 to the power x. You can easily identify that 1 plus 2 to the power 22 is an odd number. So it shares no factor with 2 to the power x. So 2 to the power x has to be a factor of 2 to the power 10, because 2 to the power x has only 2 as its prime factor, and 2 to the power 22 plus 1, that is the number in the brackets, is an odd number. So it has no common multiples, common factors with 2. So 2 to the power x is a factor of 2 to the power 10. So the largest possible value of x is equal to 10, and in that case 2 to the power x will actually equal 2 to the power 10. So the answer in this case is 10.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
In this question it is given that the arithmetic mean of x, y and z is 80. So we are told that x plus y plus z by 3 is equal to 80, or x plus y plus z is equal to 240. We are also told that the arithmetic mean of x, y, z and u is 75, or x plus y plus z plus u plus v by 5 is equal to 75. We are using 3 because there are 3 terms here, and we are using 5 because there are 5 terms here, or x plus y plus z plus u plus v is equal to 75 into 5, which is equal to 375. Based on these two equations, we can immediately conclude that u plus v is equal to 375 minus 240, which is equal to 135. We are also told some more things. We are told that u is equal to x plus y by 2 and v is equal to y plus z by 2, and that x is greater than or equal to z. Then we are required to find out the minimum possible value of x. So let us use this these two new equations, because we know that u plus v is equal to 135, and try to simplify the information that is given. So we are told that x plus y by 2 plus y plus z by 2 is equal to 135, or x plus y plus z plus y whole by 2 is equal to 135. You can take 2 to the other side, multiply both the sides with 2, so this will be 270. But we already know that x plus y plus z is equal to 240. So we can replace x plus y plus z with 240. So 240 plus y is equal to 270, or y is equal to 30. Now we also know that x plus y plus z is equal to 240. So x plus z is equal to 210, and x is greater than or equal to z. This is the information that we have, and we have to find out the minimum possible value of x. Now because x is greater than or equal to z, let us assume that x is equal to z plus k, where k is some number which is greater than or equal to 0. Therefore, as x plus z is equal to 210, it would imply that x plus x minus k, because z will equal x minus k, is equal to 210, or x is equal to 210 plus k by 2, or this will equal 105 plus k by 2. And we know that k is greater than or equal to 0. Therefore, the minimum possible value of x will happen when k equals 0 and x will equal 105. At this point, z also will equal 105, but still x will be greater than or equal to z. So the minimum possible value of x is 105. In this question, we are given two sets. We are given set A, which is 6 to the power 2n minus 35n minus 1 for n is equal to 1, 2, 3 and so on, and B is equal to 35 into n minus 1, again for all the natural numbers 1, 2, 3 and so on. So both A contains a lot of numbers, infinite numbers, and B also contains infinite numbers. What we are required to find out, if you look at the options, is whether every member of set A is present in set B or not, and similarly whether every member of set B is present in set A or not. Once we finalize this, we can select which of the 4 options is correct. So before we go to that, let us first examine both the sets thoroughly. So suppose this is set A. This contains numbers which are of the form 6 to the power 2n minus 35n minus 1 for all natural numbers n equal to 1, 2, 3 and so on. So let us first put down the elements of set A in a more numeric format. So let us substitute n is equal to 1. So members of set A when n is equal to 1 will be 6 to the power 2, which is 36, minus 35 minus 1, which is 0. Similarly, when we substitute n is equal to 2, it will be 6 to the power 4, which is around 1296, minus 35 into 2 is 70, minus 1 is 71. So this is something like 1225 or something like that, 1225. Now when you substitute n is equal to 3, you get 6 to the power 6 minus 35 into 3 is 105 minus 1 is 106 and so on. This is what set A contains. Now let us look at set B. Set B is a lot more straightforward. Set B is equal to 35 into n minus 1 for all natural numbers n, where n is equal to 1, 2, 3 and so on. Now again, if you substitute n is equal to 1, you get 0 directly. Now when you substitute n is equal to 2, this will become 35 into 2 minus 1, that is 35 into 1, which is 35. Similarly, the next one will be 35 into 2, which is 70. The next element will be 35 into 3, that is 105 and so on. This is set B. Clearly set B contains all the multiples of 35. Now if you examine set A and set B, very clearly there are elements in set B which are not present in set A. So that is the first conclusion that you should have. All members of set B are not present in set A. This is the first conclusion that you should have. If you just examine the first few members of both the sets, you can come to this conclusion. Now, so you can directly strike off answer C, which says that every member of B is in A. That is clearly not true. If you look at the other elements, if you look at the other options, then we have to figure out whether all the elements of set A are present in set B or not, because all the other options contain something of on those lines. Now let us look at a element in set A. This is something like 6 to the power 2n minus 35n minus 1. Now if all the numbers, all the elements of this set, irrespective of the value of n, if they are multiples of 35, then they will be present in set B. So if for all n, if this is a multiple of 35, it will be present in set B. If it is not a multiple of 35 for some number n, then it won't be present in set B, because set B contains only the multiples of 35. So now let us examine this. 6 to the power 2n minus 1, this is equal to 36 to the power n minus 1, which will be a multiple of 35. Similarly, when you are adding 35, if you are subtracting 35 into this whole term, this whole sum will be a multiple of 35 for all n. Because 6 to the power 2n minus 1 is a multiple of 35, and when you are subtracting 35n, which is another multiple of 35, the whole sum or the whole difference in this case will be a multiple of 35. So 6 to the power 2n minus 35n minus 1 will always be a multiple of 35, so it will always be present in set B. So all members of set A are present in set B, but the vice versa is not true. That is, all members of set B are not present in set A. This we have already identified earlier by giving a few examples like 35, 70 and 105. Now let us look at the options. We have already ruled out option C. If you look at option D, at least one member of set A is not in B. This is not true, because as we have discussed earlier, all the members of set A are multiples of 35 and every multiple of 35 is present in set B. So this is not true. If you are looking at option B, neither every member of A is in B nor every member of B is in A. This is also not true, because every member of A is in set B, although the vice versa is not true. Now let us look at option A. It says that every member of A is in B, which is true, and at least one member of B is not in A. This is also not true. So in this case, the correct answer is option A. In this question, we are given a logarithm and we are required to find out its sum. So if you look at it, all of them are in denominators. The first denominator is log 100 to the base 2. The second one is log 100 to the base 4. Third one is log 100 to the base 5 and so on. Now if you notice it, all the denominators, the base is differing, but it is all of them are for logarithm 100. Now whenever the base is the same, it is much easier to do additions of logarithms. For example, we know that log of a to the base b plus log of c to the base b is quite easy to find out. It will be log of a into c to the base b. So what we will do over here is we will convert each one of them to the base 100. Now another formula that you should remember is that log of a to the base b is equal to 1 by log of b to the base a. So when you take the denominator to the numerator, you have to reverse the base. So for example, 1 by log 100 to the base 2 will become log of 2 to the base 100 minus this will become log 4 to the base 100 and so on. So the next term will be plus log of 5 to the base 100 minus log, this one will become 10 to the base 100 plus log of 20 to the base 100 minus log of 25 to the base 100 and finally plus log of 50 to the base 100. Now notice that the base for all of these terms is 100. So we can easily multiply or divide as and when the symbol is plus or minus. So in this case, we can take a common logarithm. The base will be 100 and this will equal 2 into, because the term preceding 4 is minus, it will be 1 by 4 into 5 into 1 by 10 into 20 into, again because the term preceding log 25 is minus, it will be 1 by 25 and finally into 50. You can simplify this in any way. So 50 by 25 is 2, 20 by 10 is 2, 2 by into 1 by 4 is 1 by 2. So you can cancel these two and finally you will be left with log of 10 to the base 100. Now log of 10 to the base 100, as we all know, equals half. So the answer in this case after simplification will be half. Notice that we have used very simple formulas of logarithms. One of the formula we used is that log of a to the base b is equal to 1 by log b to the base a, and the summation of logarithms, that is whenever the base is common, when you are adding two logarithms, you just multiply both of the terms. For example, log a to the base b plus log c to the base b is equal to log of a into c to the base b. In this question, we are given that p cube is equal to q to the power 4 is equal to r to the power 5 is equal to s to the power 6, and we are required to find out the value of log pqr to the base s. So whenever you see a question where this kind of a equation is given or this kind of a relationship between different variables is given, one of the first things that you should do is equate them all to a constant k. So in this case, we will assume that p cube is equal to q to the power 4 is equal to r to the power 5 is equal to s to the power 6 is equal to a constant k. This will help us simplify the equations and simplify the relationship very easily. So for example, we know that p cube is equal to k. So p is equal to k to the power 1 by 3. Similarly, q to the power 4 is equal to k, or q is equal to k to the power 1 by 4, and r is equal to k to the power 1 by 5, and s is equal to k to the power 1 by 6. So what we are required to find out is log pqr to the base s. So we will first find out what pqr is when it is simplified. So this is equal to k to the power 1 by 3 into k to the power 1 by 4 into k to the power 1 by 5, or this equals k to the power 1 by 3 plus 1 by 4 plus 1 by 5. You can simplify 1 by 3 plus 1 by 4 plus 1 by 5. The LCM is 60. So this will be k to the power divided by 60. 1 by 3 is 20 by 60. 1 by 4 is 15 by 60. And 1 by 5 is 12 by 60. So this is k to the power 47 by 60. Now there is no need to simplify s, the base, which is already k to the power 1 by 6. So when you are required to find out log pqr to the base s, we will make it look like log of PQR by log of S. Now here we can determine both of them to the base k. So log of S to the base k is equal to 1 by 6, and using this log of PQR to the base k is equal to 47 by 60. So when we want to find out log PQR to the base S, we will find out both of them to the base k. Remember that log of a to the base b can be simplified as log of a to the base c by log of b to the base c for some number c. This is a theorem in logarithms which is very widely used. So when you are trying to calculate log of PQR to the base S, we will first find out log PQR to the base k. This we already know is equal to 47 by 60 divided by log S to the base k. This is equal to 1 by 6. So this will be 47 by 60 into 6. This is equal to 47 by 10. So the answer in this case is 47 by 10. The simple trick is ensuring that we equate all of these variables to a different variable k and then simplifying the required equation. In this question we are told that there are real numbers t1, t2, t3 etc. such that t1 plus t2 plus t3 plus dot till tn is equal to 2n square plus 9n plus 13, and this is true for all positive integers n greater than or equal to 2. We are told that tk is equal to 103 and we are required to find out the value of k. So whenever you are given a sum of this sort and a equation of this sort, we will try to find out the value of tn. That is quite easy to find out. So we know that t1 plus t2 plus t3 plus dot plus tn minus 1 plus tn is equal to 2n square plus 9n plus 13. Now what we will do is we will try to find out the value of t1 plus t2 plus dot plus tn minus 1, and then we can subtract both of them to find out the value of tn. And finding this out is actually quite easy. Now we know that t1 plus t2 plus t3 plus dot plus t of n minus 1 is actually equal to 2 into n minus 1 whole square plus 9 into n minus 1 plus 13. What we have done is just substituted n minus 1 in place of n, because we are told that this is true for all positive integers n greater than or equal to 1. If this should be true, we will just substituting n minus 1 in place of n. Now if you subtract both of them, you are going to get tn in the left hand side. So this equals 2n square plus 9n plus 13 minus of 2 into n minus 1 whole square plus 9 into n minus 1 plus 13. Let us simplify the RHS over here. This is equal to 2n square minus 2n plus 1 plus 9 into n minus 1 plus 13. So if you subtract both the equations on the right hand side, you are going to get 2n square plus 9n plus 13 minus of 2n square minus 4n plus 2 plus 9n minus 9 plus 13. Now you can cancel 2n square on both sides, you can cancel 9n on both sides, and you can cancel 13 on both sides. So this will equal 4n plus 7. This is the value of tn for all values of n. Now if we are told that for a particular value of k, tk is equal to 103, tk is equal to 4k plus 7. This we know from the equation that we have just derived. And if this equals 103, it would imply that 4k is equal to 103 minus 7, that is 96, or k is equal to 96 by 4, which is equal to 24. So in this case, the answer is 24, and this question is easily solved once we figure out that by substituting n minus 1 in place of n, we will find out the value of tn for all values of n, and we can substitute 4k plus 7 equals 103 to find the value of k. In this question, it is given that log x to the base 3 is equal to log y to the base 12 is equal to a, where x and y are positive numbers. If g is the geometric mean of x and y, we are required to find out the value of log g to the base x. So we will first find out the value of x, we will find out the value of y, then we will find out the value of g, and we will find out the value of g to the base 6. Now x is equal to 3 to the power a, because by definition log x to the base 3 is a. Similarly, y is equal to 12 to the power a, because log y to the base 12 is a. Therefore, g, which is the geometric mean of x and y, will be square root of x into y. This is equal to square root of 3 to the power a into 12 to the power a. This is equal to square root of 36 to the power a. But square root of 36 to the power a is equal to 6 to the power a. Therefore, g is equal to 6 to the power a, or log g to the base 6 is equal to a. So the answer in this case is a. In this question, we are given two logarithms and we are given an integer, and we are required to find the sum of the three terms. So let us first simplify each of them, that is log of square root of 5 to the base 0.008. Now 0.008 is equal to 8 by 1000. This is equal to 1 by 125. This is equal to 5 to the power minus 3. So the given logarithm, that is the first term of the expression, is actually equal to log of 5 to the power half to the base 5 to the power minus 3. So whenever you have logarithm of x to the power a and to the base y to the power b, this can be simplified as a into logarithm of x by b to the base y. So whatever is there as the power of x will be in the numerator, and whatever is there which is the power of y will be in the denominator. Similarly, using the same formula over here, this can be simplified as half divided by minus 3 log of 5 to the base 5. Clearly log 5 to the base 5 is equal to 1. So this entire term can be simplified to equal minus 1 by 6. Similarly, if you are trying to simplify log of 81 to the base square root of 3, this is equal to log of 3 to the power 4 to the base 3 to the power half. We can use the same formula that we have used earlier, and this is simplified to 4, which is the power of 3 in the numerator, divided by half, which is the power of 3 in the base. So this is log 3 to the base 3. This is again 1, but 4 by half is equal to 4 into 2, which is equal to 8. So this is equal to minus 1 by 6, and this is equal to 8. So the total sum is minus 1 by 6 plus 8 minus 7. This is equal to 1 minus 1 by 6, which is equal to 5 by 6. So the answer in this case is 5 by 6. In this question, we are given an equation 9 to the power 2x minus 1 minus 81 to the power x minus 1 is equal to 1944, and we are required to find out the value of x. So if you notice, you have 9 to the power x in the first term and 81 to the power x in the second term, but 81 to the power x is equal to 9 to the power 2x. So what we will do is we will assume that 9 to the power 2x is equal to a. So we will first solve for a, and from that we can find out the value of x. So 9 to the power 2x minus 1 is equal to 9 to the power 2x by 9, which is equal to a by 9. Similarly, 81 to the power x minus 1 is equal to 9 to the power 2 into x minus 1, which is 9 to the power 2x minus 2, which is equal to 9 to the power 2x by 81. So this is equal to again a by 81. So the required equation can be simplified as a by 9 minus a by 81 is equal to 1944, or 8a by 81 is equal to 1944, or a is equal to 1944 into 81 by 8. Now you can simplify 195, we can divide 1944 by 8, and the answer is 243. So this is equal to 3 to the power 5, which is 243, into 3 to the power 4, which is equal to 81. So this is equal to 3 to the power 9. So 9 to the power 2x is equal to 3 to the power 9. Now we will again simplify 9 to the power 2x as 3 to the power 4x, because 9 is equal to 3 square, is equal to 3 to the power 9, or 4x is equal to 9, or x is equal to 9 by 4. So the value of x is 9 by 4. In this question, it is given that A, B, C, D, E, F, G, H and J, K are 5 diameters of a circle with center O. So suppose this is the circle, this is the center O. There are 5 diameters. And this. So these are the 5 diameters of the circle with center O. In how many ways can 3 points be chosen out of A, B, C, D, E, F, G, H, J, K and O so as to form a triangle? So total there are 5 diameters, so there are 10 points plus the center, so there are 11 points, and using these 11 points we need to form a triangle. So we need to choose 3 points out of this 11. So the total number of ways of choosing 3 points out of 11 is 11C3. 11C3 we will calculate, but out of these points that are selected, there will be some points which are collinear. That is, there will be 3 points which are on the straight line. Whenever there are 3 points on the straight line, we can't form a triangle. Now if you look at these 11 points, there are 5 such triplets which are collinear. These are actually the ones that are already given to us. That is, the 5 diameters AB, CD, EF, GH and JK. If the 3 points that are chosen include the center, that is, if the points chosen are A, B and O, they will be on a straight line, so they can't be chosen. Similarly, if they are if the 3 points chosen are C, D, O, again they will be on the straight line, so again they don't form a triangle. So the total number of triangles that are formed are 11C3, which is all the ways in which we can select 3 points out of 11, minus these 5 special cases, because all 5 of them form a straight line and not a triangle. So we can simply calculate the value of 11C3. This is 11 into 10 into 9 by 3 factorial, that is 6. So you can cancel the common terms. So it will be 15 into 11, which is equal to 165 minus 5, so 160. So you can select 3 points out of this 11 in 160 ways such that the 3 points form a triangle. In this question, it is given that the square of the 7th term of an arithmetic progression with positive common difference equals the product of the 3rd and 17th terms. We are required to find out the ratio of the first term to the common difference of the arithmetic progression. So let us assume that the first term of the arithmetic progression is A and the common difference is D. We are told that the common difference is positive, so D is greater than 0. So the 7th term of the arithmetic progression will equal A plus 60. Similarly, the 3rd term will equal A plus 2D and the 17th term will equal A plus 16D. We are told that the square of the 7th term, that is A plus 6D whole square, is equal to the product of the 3rd and 17th term. So that will equal A plus 2D into A plus 16D. You can simplify this. So this will be A square plus 12AD plus 36D square is equal to A square plus 2AD plus 16AD plus 32D square. You can cancel the common terms and you can bring all the terms of D square on one side. So that will be 36D square minus 32D square is equal to 4D square equals 2 plus 16, that is 18AD minus 12AD, so that will equal 6AD. Again you can divide both the sides with 2D because D is greater than 0. So this would imply that 2D is equal to 3A, or A by D, which is the ratio of the first term to the common difference, is equal to 2 by 3. So the required answer is 2:3.
In how many ways can 7 identical erasers be distributed among 4 kids in such a way that each kid gets at least 1 eraser but nobody gets more than 3 erasers? This is a pretty simple partitioning question. Anybody who has had some basic idea of how to do partitioning should be able to answer this question. So we basically have to give 7 identical erasers among 4 kids such that each gets at least 1 eraser. So we start off by just giving off 1 eraser to all the 4 kids. So now after I have given away the 4 erasers to each of those 4 kids, I am left with 3 erasers. Now I have to distribute these 3 erasers among the 4 kids in such a way that nobody gets more than 3 erasers. So let's say the erasers gotten by the first kid are A, by the second kid are B, by the third kid are C, and by the fourth kid are D. So I'm saying that A plus B plus C plus D is equal to 3, and nobody should get more than 2 erasers. That means A, B, C and D should be less than or equal to 2. 2 because I've already given 1 eraser, so I can give at max 2 more. So this should be less than or equal to 2, and as this is we can't give negative values as such, this should be at least 0. So this is what we have. We have an equation, where linear equation where we have 4 variables, A plus B plus C plus D is equal to 3, and the limit on the equation is that A, B, C, D can vary between 0 to 2. Now if you have had some basic idea of partitioning, we know that when we have to partition n identical things, I'll put identical, n identical things in R partitions where there is no limit as such, where I don't have to give at least 1 or anything, nothing of that sort is there, then that can be done in n plus R minus 1 C R minus 1 ways. So I'll ignore this 2 limit for a second. So if this 2 limit is not there, and there are 4 people and 3 erasers, and I can distribute in any ways I can. So 3 identical items can be distributed among 4 people in 3 plus 4 minus 1 C 4 minus 1 ways. This is equal to 6C, this is 6C 3 ways, that is essentially 20 ways. But there is an additional requirement that nobody should get more than 3 erasers, that is A, B and C, A, B, C, D should be less than or equal to 2. So essentially we just have to remove the cases where they are equal to 3. So in what we do generally in these cases where you have a upper limit is where you write down each variable as say P is 2 minus A and Q as 2 minus B and so on. Then substitute the equation so that you do not have the upper limit as such. Firstly, in this case, this representation would not help because you still have a limit which is lower than the sum. Secondly, it's not needed also, because if you can see this value, this limit is 2 and the other limit, actual limit, if you consider without this, is 3. So only one case exists where one of the students gets 3 rubbers and the others does not get any rubber. So the number of ways in which a particular student can get 3 rubbers is 3 erasers. If like say A gets 3 erasers, then the remaining does not, remaining 3 guys don't get anything. Or if B gets 3 erasers, then remaining 3 guys get nothing. So the number of ways that one student can get more than 3 erasers, or like A, B or C is greater than 2, is if either of these variables is equal to 3. This can occur in essentially 4 ways, because there are 4 variables. So in 4 ways that particular limit, this particular limit is exceeded. So our the number of ways in which we can distribute is essentially 20 ways minus these 4 ways, because these 4 ways are invalid. So the total number of ways is 16 ways. So as you can see in this case, we just had to first ignore the limit, find out what is the total number of ways when if there was no limit such that nobody gets more than 3 erasers, find out the total number of ways, and then find out how many ways can somebody get more than 3 erasers. Somebody can get more than 3 erasers in only 4 ways, where one person gets 4 erasers and the others gets 1 each. Now you can select the person who gets 4 erasers in 4 ways. So you deduct those 4 ways from the 20 ways and you get the answer. So this is how we solve questions where we have to do partitioning. This method is the general approach in case there is an upper limit for the variable, but it was not applicable in this case. You could have solved it without using that concept. In fact, you could not have solved it using this concept. If you try it out later, you can see that the partition, this particular method would not help. But we did not need it because this method was easy enough for us to calculate, because the upper limit was just one short of the actual limit. So this is how we solve this particular question. Consider the following question. Let a1, a2 till a is to 3n be an arithmetic progression with a1 equal to 3, a2 equal to 7 and so on. If a1 plus a2 till a plus a3n is 1830, then what is the smallest positive integer n such that m times a1 plus a2 plus till an is greater than 1830? So essentially this is a pretty simple question as such. This is you just have to find the value of m such that this sum is greater than 1830. The only thing that you needed to remember to solve this question is the formula of sum of AP. So the sum of an AP is equal to, if the AP is of the form a plus d and so on, where a is the first term and d is the common difference, then the sum till n terms is given by n by 2 times 2a plus n minus 1 d. If you knew this basic concept, you can solve any question as such. So it's a pretty easy question if you know this basic formula. So let's take a look at how to solve this question. So we know that the equation, the progression is a1 is equal to 3, a2 is equal to 7. So if a2 is equal to 7, d is equal to basically 7 minus 3, that is 4, and the first term is 3. So we can find out the sum of the first 3 n terms as such. So sum of first 3 n terms is equal to 3n by 2 times 2a is basically 2 times 3, that is 6, plus 3n minus 1 times d, that is 4. So this is basically what we get. So we get 3n by 2 times, expanding the bracket, I get 6 plus 12n minus 4. So this is essentially 3n by 2 times 12n plus 2. Cancelling 2 out, I get this value as 3n times 6n plus 1, and this is equal to 1830. I can cancel 3 on both sides. Cancelling 3, I get this is 610. So 6n plus 1 is equal to 610. Now, 6n plus 1 in n into 6n plus 1 is equal to 610. So I get a quadratic equation. So I can write this down as 6n square plus n minus 610 is equal to 0. Now to factorize this quadratic equation, we need a pair such that the product is 6 into 610 and the sum is 1. Now the sum is 1 and the product is minus 6 into 610. That I can get if this are 61 and 60. In that case, if it is 61 and minus 60, the sum will be 1 and the product will be minus 6 times 600, minus 6 into 610. So I can write this equation as 6n square plus 61n minus 60 is n minus 610 is equal to 0. So I can write this equation as 6n times 6n plus 61 minus 10 into 6n plus 61. This is equal to 0. So n is equal to either 10 or it is equal to minus 61 by 6. Now as n is the number of terms, it cannot be a negative value. So I can cancel, I can ignore this value. So n must be equal to 10. Now if n is equal to 10, we have to find out what is a1 plus a2 till an. So sum of n numbers would be, sum of a1 to an would be n would be n by 2 in, so this is 10 by 2 into 2a is 6 plus n minus 1 will be 9 times d, that is 4. So this is 36 plus 6, 42, 42 into 10 divided by 2, this is equal to 210. So we have to find out a m such that m times 210 is greater than 1830. So I have to find the least possible value of m such that m into 210 is greater than 1830. So m must be greater than 1830 by 210. I can cancel this. This is essentially 0, 0 I cancel, then divide by 3. So this is 7, this is 61. So m is the least integer greater than 61 by 7. So 61 by 7 is 8 point something, 8.71 or something like that. So the least value of least smallest positive integer m such that this value is greater than 8.71, So the least positive integer greater than 8.71 is 9. Therefore, the answer to this question is 9. So this is how we could solve this question. As you could see, the only thing that we needed to remember what was the sum of an AP. And once you knew what the sum of AP was, you got basic equations that you could then solve. You also needed to know how to factorize a quadratic equation. But if you knew these basic, very fundamental concepts, you could actually solve this question. The numbers 1, 2 to 9 are arranged in a 3 into 3 square grid in such a way that each number occurs once and the entries along each column, each column, each row and each of the two diagonals adds up to the same value. If the top left and the top right entries of the grid are 6 and 2 respectively, then the bottom middle entry is. So what we have been given is that there is a 3 into 3 grid of this sort, and this is 6 and this is 2, and the sum along each of the rows, each of the columns and each of the diagonals, two diagonals, so this number and this number, all of these 5, 6, 7, 8 numbers are equal. Now if all the 3 rows are equal, then each of them should be 1/3 of the total possible sum of numbers from 1 to 9. So the sum of numbers from 1 to 9, as we know, is 45. So each of these row totals should be 15. Similarly, each of these column totals should also be 15. The diagonal totals should also be 15 then. So this is how we get this as such. So now that we have this information, let's see what would be the possible configuration of this grid. So we have been told that the value along each column, each row and each of the two diagonals adds up to the same value. So this value is 15. So we have already placed 6 and 2, so that is 8. So 15 minus 8 is 7. So this missing value should be 7. Now what we have remaining is 2 is done, so I will remove 2. 3, 4, 5, 6, 7, 8, 9. So 6 is done, 7 is done and 2 is done. Now we have 1, 3, 4, 5, 8 and 9. Now let's consider the case of 9. If we put 9 in this row, in this column as such, the first column, the sum would be 15 already with 6 and 9. Then there would be no value that can take the third cell as such. So 9 cannot be in this column. Similarly, if 9 is in this column, the sum would be 16, which would exceed this 15 value as such. So 9 cannot be in this column either. So the 9 has to be in this column. Now we know that the sum along the diagonal is also 15. So if 9 is in this place, in the bottom row in the third column, then this sum alone would be 15 and no value can take this middle cell as such. So the 9 cannot be here, therefore the 9 has to be here. Now this column total is 15, this is 11, so this must be 4. So we have placed 4 and 9 also. Now let's consider 8. Now if we place 8 in this column, that sum alone would be 15. And then we can't place anything in the third cell in the same column. So 8 can't be in this column, 8 has to be in this column as such. Now 8 can be, if 8 is over here, the column row sum of this row would be more than 17 as such. So 8 cannot be in this row, so 8 has to be in this row. Now now that we know that this sum along the diagonal is equal to the sums along the rows and columns. Since this is 6 and 4, this must be 5. If this is 5 and as we see this is 13 plus 2, 15, so the condition is satisfied. We have placed most of the elements now. Now just considering the row total here is 15, so this must be 3, and the row total here is 15, so this must be 1. So we have placed all the elements from 1 to 9. Therefore we are asked what is the bottom middle entry. The bottom middle entry is 3. Therefore the answer to this question is 3. So as you could see, this did not require any knowledge as such. This was more of a logical reasoning question than a quant question as such. The only thing that you needed to calculate was that if you're given that the row totals, column totals and diagonal totals are equal, the row totals can be 1/3 of the sum of the 1 to n as numbers as such. So you just needed to know how to sum up 1 to 9 quickly, and 1/3 of that you would get the row totals and column totals, and then just by using simple logical reasoning you could solve the remaining question as such. So as you could see, this did not require any prior knowledge of any formula as such. So this was a pretty easy question for you to solve had you not had any other experience with any other formulas, or you have not prepared. Even then you would have been able to solve this question.
In this question, we are told that x is a real number such that log of 5 to the base 3 is equal to log of x plus 2 to the base 5, and we are required to find out an interval within which x will lie. So let us first understand how log 5 to the base 3, what is the actual value of this. We know that log 5 to the base 3 will be greater than log of 3 to the base 3. Why is this greater than log 3 to the base 3? Because 5 is greater than 3. And what is the value of log 3 to the base 3? This is equal to 1. We also know that log of 5 to the base 3 is less than log of 9 to the base 3. Why is this the case? Because 5 is less than 9. And what is the value of log 9 to the base 3? It is equal to 2. So we know that the left hand side, that is log 5 to the base 3, lies between 1 and 2. Therefore, log of x plus 2 to the base 5 also lies between 1 and 2. So now let us we'll eliminate the base. So we know that x plus 2 will therefore lie between 5 to the power 1 and 5 to the power 2, or x plus 2 has to lie between 5 and 25. Now subtracting 2 from all the sides, we know that 3 has to be less than x, which is less than 23. Now this is something that we know for sure, and there is only one option which actually satisfies it, which is option D. So the correct answer is option D. In this question, we are given an equation. It has 9 to the power x and 4 to the power x and 2 to the power 2x and 3 to the power x. We are required to find out the value of x. So what we will do first is we will segregate the terms having 3 to the power x or 3 to the power 2x, and all the terms having 2 to the power x or 2 to the power 2x on one side. So if you look at the equation that is given, it is 9 to the power x minus half minus 2 to the power 2x minus 2. This is equal to 4 to the power x minus 3 to the power 2x minus 3. So the first thing we will do is we will convert 9 into 3 square, and we will convert 4 into 2 square. So this will be 3 to the power 2x minus 1 minus 2 to the power 2x minus 2 is equal to 2 to the power 2x minus 3 to the power 2x minus 3. The second step to do it is bring all the terms containing 3 on one side and all the terms containing 2 on the other side. So this will become 3 to the power 2x minus 1 plus 3 to the power 2x minus 3 is equal to 2 to the power 2x plus 2 to the power 2x minus 2. Now what you should notice is that if you assume that 3 to the power 2x is equal to a, 3 to the power 2x minus 1 will be a by 3. And 3 to the power 2x minus 3 is equal to 3 to the power 2x by 3 cube. So this is equal to a by 27. So the required sum over here is a by 3 plus a by 27. This is equal to a into 9 plus 1 by 27 or a into 10 by 27. So the left hand side becomes 3 to the power 2x into 10 by 27. Similarly, let us assume that 2 to the power 2x is equal to b. So this becomes 2 to the power 2x minus 2 is equal to b by 4, because this is 2 to the power 2x by 2 square, so that is b by 4. So the sum of 2 to the power 2x and 2 to the power 2x minus 2 is b into 1 plus 1 by 4 or b into 5 by 4. So the right hand side becomes 2 to the power 2x into 5 by 4. Now we can cancel 5 on both sides. So 3 to the power 2x by 27 is equal to 2 to the power 2x by 8. Now you will get an idea of where we are going with this. Now we can assume that 3 to the power 2x by 2 to the power 2x is equal to 27 by 8, or 3 by 2 whole to the power 2x is equal to 3 by 2 whole cube. Notice that 27 by 8 is 3 by 2 whole cube. This would imply that 2x is equal to 3, or x is equal to 3 by 2. So the value of x which we are supposed to calculate is 3 by 2.
Google search Krakow free CAT mock. Click on the first link. You can attempt a free mock test which was attempted by 30,000 CAT aspirants in the actual exam format. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solution to get video solutions from our expert faculty.
In this question we are told that log of 2 to the power a into 3 to the power b into 5 to the power c is the arithmetic mean of log of, we are given 3 logarithms and we are required to find out the value of a. So let us first calculate the arithmetic mean of these 3 logarithms that are given. Arithmetic mean is the average of the 3 logarithms that are given. So this is log of 2 square into 3 cube into 5 plus log of 2 to the power 6 into 3 into 5 to the power 7 plus log of 2 into 3 square into 5 to the power 4 whole divided by 3. Now we know that log of a plus log of b is equal to log of a into b. This is the basic property of logarithms. We will apply the same thing over here. So this will be 1 by 3 into log of this number into this number into this number. Now what we will do is we will collect all the powers of 2 to one side, all the powers of 3 to the other side and all the powers of 5 to the other side. So the powers of 2 will be 2 square plus 6 plus 1. So this will be 2 to the power 2 plus 6 plus 1 into the power of 3 will be 3 plus 1 plus 2 and the power of 5 will be 1 plus 7 plus 4. This will equal 1/3 into logarithm of 2 to the power 2 plus 6 plus 1 is 9 into 3 to the power 3 plus 1 plus 2 is 6 into 5 to the power 1 plus 7 plus 4 is 12. Now again we know that 1 by 3 log of a or any number to the power of which is negative, which is less than 1 will equal log of a to the power 1 by 3. We can take this fraction or this number and take it inside the logarithm by making it to the power of. So we will do the same thing over here. So this will equal log of 2 to the power 9 into 3 to the power 6 into 5 to the power 12 whole to the power 1 by 3. This is equal to log of 2 cube into 3 square into 5 to the power 4. Now but this equals 2 to the power a, this equals log of 2 to the power a into 3 to the power b into 5 to the power c. Therefore the value of a is equal to 3. Similarly b will equal 2 and c will equal 4. In this question we are told that a1, a2, a3 till a5 is a sequence of 5 consecutive odd numbers. So the numbers a1, a2, a3, a4 and a5 are 5 consecutive odd numbers. So the difference between a pair of them is 2 consecutive pair of them. So we'll assume that the middle term is constant, which is a3. So a4 will be a3 plus 2 and the fifth term will be a3 plus 4. Similarly a2 will be a3 minus 2 and a1 will be a3 minus 4. Notice that they are consecutive odd numbers, so we have just fixed the middle term. Now consider a new sequence of consecutive even numbers ending with 2a3. So here we are assuming that there are 5 consecutive even numbers which end with 2a3. So the even number before 2a3 will be 2a3 minus 2, and the one before that will be 2a3 minus 4, and the one before that will be 2a3 minus 6, and the first number of these 5 numbers will be 2a3 minus 8. These are 5 consecutive even numbers which end with 2a3. Now we are told that the sum of the numbers in the new sequence is 450. So the sum of these 5 numbers is 450. We are required to find out the value of a5. We are required to find out the value of a5, that is we are required to find out the value of a3 plus 4. So we can easily calculate the sum 2a3 minus 8 plus 2a3 minus 6 plus 2a3 minus 4 plus 2a3 minus 2 plus 2a3 is equal to 450. So if you segregate all the terms containing a3 on one side, this will be 10a3, and the constant term will be 8 plus 6 is 14, 14 plus 4 is 18, 18 plus 2 is 20. So it will be 10a3 minus 20 is equal to 450, or 10a3 is equal to 470, or a3 is equal to 47. But notice that we have to calculate the value of a5, which is equal to a3 plus 4. So the value of a5 will be 51. In this question it is given that in how many ways can 8 identical pens be distributed amongst Amal, Bimal and Kamal such that Amal gets at least 1 pen, Bimal gets at least 2 pens and Kamal gets at least 3 pens. So we are told that there are 3 people, Amal, Bimal and Kamal. We need to distribute a total of 8 pens amongst them such that Amal gets at least 1 pen, Bimal gets at least 2 pens and Kamal gets at least 3 pens. Now all these 8 pens are identical. So what we'll do is we'll first distribute the minimum number of pens that we should give each one of them. So after distributing 1 plus 2 plus 3, that is 6 pens, we'll have a total of 2 pens remaining, and we have to distribute them amongst A, B and K. Now it is quite simple. We need to find out the number of solutions which are non-negative integral solutions for the equation A plus B plus C is equal to 2. Now we know the formula for the number of non-negative integral solutions for A plus B plus C plus dot 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 plus L such that there are R of them, which is equal to N. Now this is equal to N plus R minus 1 C N. This is the number of non-negative integral solutions for the equation A plus B plus C, where there are R variables and their sum is N. So we'll apply the same formula over here. In this case, N is equal to 2, R is equal to the number of variables, which is equal to 3. So the required answer will be 3 plus 2 minus 1 C 2. So this is equal to 4 C2, which is equal to 6. So the answer in this case is 6.
How many 4-digit numbers which are divisible by 6 can be formed using the digits 0, 2, 3, 4, 6 such that no digit is used more than once and 0 does not occur in the leftmost position? So we have to find how many numbers are divisible by 6. So for a number to be divisible by 6, the sum has to be, sum should be divisible by 3. And the last digit should be even. So last digit should be even. So that should be either 0 of the given numbers, it should be 0, 2, 4 and 6. So let's first start by putting the last digit. If the last digit, so there are 4 different cases. First is last digit is 0. Case 1. Case 2 is last digit is 2. Case 3 is last digit is 4. And case 4 is last digit is 6. So these are the 4 possible cases for the number to be divisible by 6. It has to be an even number first. So these are the 4 cases. Now let's try to see how many of them are 4-digit numbers such that the sum of those digits is also divisible by 3. So we have the last digit as 0. So the remaining 3 digits can be, so if we consider the digits that are left, if the last digit is 0, this is 1, 2, 3, the remaining digits are 2, 3, 4 and 6. So if we take 2, 3 and 4, the sum is divisible by 3. So the digits can be 2, 3, 4. This will lead to 3 factorial cases. If we drop in this case we dropped 6. Now suppose we drop 4. If we drop 4, the digits are 2, 3 and 6. The sum will not be divisible by 3. So it can't be 2, 4, 6, 2, 3, 6. Now suppose we drop 3. So the numbers are 2, 4 and 6. So 2, 4, 6, 0, the sum is divisible by 3. The sum is 12. So the sum is divisible by 3. So the digits can be 2, 4 and 6. Again, this will lead to 3 factorial numbers. Then the last, this is dropping 2. So the numbers will be 3, 4, 6 and 0. 3, 4, 6 and 0, the sum is 7 plus 6, 13. So that is not divisible by 0. So that does not lead us to a favorable case. So the number, these 3 remaining digits can be either 2, 3, 4 or 2, 4, 6. Each of these numbers 2, 3, 4 can be arranged in 3 factorial ways, and these numbers 2, 4, 6 can also be arranged in 3 factorial ways. So when the last digit is 0, we'll have 2 into 3 factorial cases. Now let's consider the case where the last digit is 2. So we have the last digit 2 here. The remaining digits are 0, 3, 4 and 6. Now suppose we consider the last 4 digits as 3, 4 and 6. If the digits are 3, 4 and 6, then the sum is 7 plus 13 plus 2, 15. So the digits can be 3, 4 and 6. Now first we drop 0. Now suppose we drop 3. The remaining digits will be 0, 4 and 6. Now 0, 4 and 6, the sum will be 12. So the sum is divisible by 3. So the remaining 3 digits can be 0, 4 and 6. Now suppose we drop 4. Then the digits will be 0, 3, 6 and 2. The sum in this case is 11. So it is not divisible by 3. So the remaining 3 digits cannot be 0, 3, 6. Now suppose we drop 6. The remaining digits would be 0, 3, 4. In this case that is 3 plus 4 plus 9, that is 9. So it is divisible by 3. So the remaining 3 digits can be 0, 3, 4. So 3, 4 and 6, if these are the 3 digits, they can be arranged among themselves in 3 factorial ways. If it is 0, 4 and 6, the first digit can be chosen in 2 ways. It can be either 4 or 6, and then the remaining 2 digits can be arranged among themselves in 2 factorial ways. So that is 2 into 2 factorial. Similarly, the first digit, if the digits are 0, 3, 4, the first digits can be either 3 or 4. That is, it can be chosen in 2 ways, and the remaining digits can be arranged among themselves in 2 factorial ways. So we get this value as 3 factorial plus 2 into 2 factorial plus 2 into 2 factorial, that is 4 into 2 factorial. Now let's consider the case where the last digit is 4. So these are the 4 digits. This is 4. So the remaining digits are 0, 2, 3 and 6. Suppose the digits are 0, 2, 3, then the sum is 5 plus 9. So the digits can be 0, 2, 3. Now suppose we drop, in this case we dropped 6. Suppose we drop 3. The digits would be 0, 2, 6 and 4. So the sum is 12. So the remaining digits can be 0, 2, 6. Now suppose we drop 2. So the digits will be 0, 3, 6 and 4. The sum is 13. So that is not possible. Now suppose we drop 0. The digits would be 2, 3, 4 and 6. The sum in that case would be 15. So that is possible. So we have 2, 3, 6. So 2, 3, 6, if these 3 digits are 2, 3, 6, they can be arranged among themselves in 3 factorial ways. If these are 0, 2, 6, they can be arranged among themselves in 2 into 2 factorial ways. Similarly, if they are 0, 2, 3, again into 2 into 2 factorial ways. Suppose the last digit is 6. So we get the remaining digits as 0, 2, 3 and 4. In this case, let's consider one by one. If we drop 0, the remaining digits are 234 and that satisfies the given condition. If we drop 0, it is 3, 4 and 6, 0, 3, 4, 6. The sum would be 13, that is not divisible by 3, so that is not possible. Suppose if we drop 3, it is 0, 2, 4, 6, so 0 to 4 is possible. Now suppose we drop 4, that is 0, 2, 3 plus 6, that is sum is 11, so even that is not possible. So in this case, if it is 3, 2, 3, 4, these 3 digits can be arranged among themselves in 3 factorial ways. If it is 0, 2, 4, the first digit can be taken in 2 ways and the remaining digits can be arranged among themselves in 2 factorial ways. Therefore, let's count the number of ways we have gotten. This is 2 into 3 factorial plus 3 factorial plus 4 into 2 factorial plus this is 2 into 2 factorial plus 2 into 2 factorial plus 3 factorial. So I got another 3 factorial plus 4 into 2 factorial plus this is 2 into 2 factorial plus 3 factorial. So 2 into 2 factorial. So I get a total of 2, 3, 4, 5. 5 into 3 factorial plus I have 4, 8 and 2, that is 10 into 2 factorial. So 2 factorial is nothing but 2 and 3 factorial is 6. So 6 into 5 is 30 plus 20. So the total number of ways is 50 ways. So the total number of 4 digit numbers that can be formed such that they are divisible by 6 is 50 numbers. So this is how we answer question. This, as you could see, this required you some knowledge of permutation and combination, and it basically required you to use enumeration. You could have done it in a shorter way, but I always recommend having mutually exclusive exhaustive cases like the last digit is 0, last digit is 2, last digit is 4 and last digit is 6, because each of these cases is exclusive case. And then if you count it, you won't be double counting and you won't skip counting. So because of that, it becomes very easy for you to not make a mistake if you have clearly defined mutually exclusive, collectively exhaustive cases like this. So as you could see, this required you some basic knowledge of PNC as such.
In this question, it is given that there is a geometric progression a1, a2 dot dot dot. We are told that this is an infinite geometric progression such that an is equal to 3 into an plus 1 plus an plus 2 plus dot 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 till infinity. So let us assume that the first term is equal to a1 of the geometric progression and the common difference is equal to r. We are also told that a1 plus a2 plus dot 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 till infinity is equal to 32, and we are required to find out the value of a5. So if you look at it, we are given two equations and we have two unknowns. The two unknowns are a1 and ar, and we are given two equations. So we'll try to solve for the two equations, find out the value of a1, find out the value of ar, find out the value of r, and then find out the value of the fifth term. Now what exactly does the first equation represent? The first equation says that an is equal to 3 into an plus 1 plus an plus 2 plus dot 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 till infinity. But what exactly does this sum equal? This sum will equal an plus 1 by 1 minus r. Remember that whenever you have a geometric progression whose first term is a and common difference is r, and when we are told that this is an infinite geometric progression, that is the modulus of r will be less than or equal to 1. That is, the geometric progression is converging. In that case, the sum of the geometric progression, that is the sum of all the numbers in the geometric progression, will equal a by 1 minus r. In this case, an plus 1, an plus 2, an plus 3 dot 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 themselves represent a geometric progression, in which case the first term of the geometric progression is a by n plus 1, an plus 1, and the common and the geometric ratio will be r, the common ratio. So the sum an plus 1 plus an plus 2 plus dot 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 will actually equal an plus 1 by 1 minus r. So when we are told that an is equal to this, we can transform this equation into an is equal to 3 into an plus 1 by 1 minus r. But again, an plus 1 is actually equal to an into r. So you can cancel off an and you will be left with 1 minus r is equal to 3r, or 1 is equal to 4r, or r is equal to 1 by 4. So whenever you are told that this is satisfied for all n, you know that r is equal to 1 by 4. Next, let us see what the second equation represents. The second equation represents that a1 plus a2 plus a3 plus dot 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 is equal to 32, or a1 by 1 minus r is equal to 32. Now we already know that r is equal to 1 by 4, so 1 minus r is 3 by 4, so this becomes a1 divided by 3 by 4 is equal to 32, or a1 is equal to 32 into 3 by 4, which is equal to 24. So now you have the first term of a geometric progression which equals 24, and you have the common difference which is equal to 1 by 4. So the value of the fifth term a5 is quite simple. This is equal to a1 into r to the power 4. So that is 24 into 1 by 4 to the power 4. You can simplify this. You are going to get 24 by 16 into 16, 32. So this equals 3 by 32, which is the answer. In this question, we are given that a1 is equal to 1 by 2 into 5, a2 is 1 by 5 into 8, and a3 is 1 by 8 into 11, and so on. And we are required to find out the sum of the first 100 terms of this series. So the first thing we'll do is we'll identify what exactly is the 100th term, that is what is a100. If you notice, in a1 the first term is 2, which is 3 minus 1. In a2 the first term is 5, which is 6 minus 1. In a3 the first term is 8, which is 9 minus 1. Similarly, in a100 the first term will be 3 into 100, that is 300 minus 1, so that is 299, and the second term therefore will be 302. The next thing you should observe is that in each of these terms the two numbers are differing by 3, that is 5 and 2 the difference is 3, 8 and 5 the difference is 3, 11 and 8 the difference is 3. Whenever the difference between the two terms in the denominator is constant, finding the sum is not very difficult. What we'll try to do is we'll transform each of these an's into a summation, into either an addition or a subtraction of two different numbers which get cancelled. For example, a1 in this case is 1 by 2 into 5. Notice that the difference between 2 and 5 is 3. So what we'll do is we'll look at it as 1 by 3 into 5 minus 2 by 2 into 5. This is equal to 1 by 3 into 1 by 2 minus 1 by 5. Notice that 1 by 2 into 5 is exactly equal to 1 by 3 into 1 by 2 minus 1 by 5. Similarly, a2 is equal to 1 by 5 into 8, which is equal to 1 by 3 into 1 by 5 minus 1 by 8. And a3 is equal to 1 by 8 into 11, which is equal to 1 by 3 into 1 by 8 minus 1 by 11. Why exactly are we doing this? Because we want to get the terms cancel each other, whichever term is common. For example, over here there is minus 1 by 5, which is the second term of a1, and here 1 by 5 is the first term of a2, which is positive. So when you are adding all of this up, you can cancel all the terms, all the respective terms will get cancelled, and finally you will be left with a100, which is equal to 1 by 299 into 302, which is equal to 1 by 3 into 1 by 299 minus 1 by 302. Again, the 1 by 299 in a of 100 will get cancelled with the 1 by 299 in a of 99. So all the terms get cancelled. The only two terms which will remain are the first term, which is 1 by 2, and the last term of a100, which is 1 by 302. So the entire sum of a1 to a100 will get transformed into 1 by 3 into 1 by 2 minus 1 by 302. Now you can simplify this. This will be 300, 1 by 3 into 300 by 2 into 302. You can cancel 1 by 3, this becomes 100, or this becomes 50, and after you cancel the 2, so it is equal to 50 by 302. You can simplify this and this will become equal to 25 by 151. So the answer in this case is 25 by 151. Whenever you get this kind of a series, what you have to do is first identify what is the 100th number. Then try to see if you can split each of the an's into two different terms such that the consecutive an's cancel each other. In this case, the second term of a1 is exactly equal to the first term of a2 with a different sign. So you can cancel each other off whenever you are adding all of them. And finally, you will be left with 1 by 3 into 1 by 2 minus 1 by 302, which when you simplify equals 25 by 151.